Welcome to Sleepy Science Quest channel. Take a moment to settle in, adjusting your pillows and letting your body sink into comfort. You have found a quiet place to rest your mind. On this channel, we believe in the power of slow storytelling narratives that flow like a gentle stream, designed to help you disconnect from the rush of the world and drift peacefully towards sleep. Tonight's story, titled "We Traveled 50 Years into the Future. We Regret It," takes us beyond the edge of the known universe. It is a tale of scientific wonder, the relativity of time, and the profound silence of deep space. We will follow explorers as they chase the speed of light, seeking answers in the curvature of the cosmos, only to find that the future is not quite what they expected. So, close your eyes, take a deep, slow breath, and let the tension of the day dissolve. Imagine the soft, rhythmic hum of a spacecraft, the infinite black velvet of space outside, and the distant, steady light of the stars. The journey is about to begin. The hum of the ion runner was a vibration that Cale felt in his teeth more than he heard with his ears. He sat strapped into the navigation chair, his fingers hovering over the glass interface of the console. Outside the reinforced viewports, the stars of the solar system were steady points of light. But that was about to change. They were preparing for a burn that would push the limits of physics, a journey that would take them far beyond the edge of everything Cale had ever known. Captain Elara Vance floated into the cockpit, gripping the handholds with the ease of someone born in zero gravity. She didn't look like a physics professor, but out here in the black, she was the only teacher Cale had. "Nervous?" Elara asked, strapping herself into the pilot's seat. "A little," Cale admitted. He looked at the chronometer on the dashboard. It ticked away rhythmically. "It's the time shift. I still can't wrap my head around it. The idea that we leave today, but when we come back, everyone we know might be old or gone." Elara nodded, her expression serious. "Time is not absolutely defined, Cale. In an obvious sense, we are all time travelers. Even back on Earth, if you sit in a chair and do nothing, you are being moved forward into the future at the steady pace of 1 second per second. But that is boring. That is of limited interest to explorers like us." She tapped a sequence of commands, priming the engine core. To be a true time traveler, you need to leap forward. You need to reach the future sooner than everyone else. Can it be done? Indeed it can. We have known the formula for centuries. Einstein, Cale said. It was the first name they taught in the academy. "Correct. 1905, Elara said, bringing up a holographic display of the engine's projected output. Albert Einstein was the first to show that time travel is possible. He did this by destroying the old common-sense picture of time that dated back to Isaac Newton. He replaced it with the concept of relative time." Cale watched the energy readings climb. "He was a genius. He was 26, Elara corrected with a faint smile. "He wasn't the old man with messy grey hair and a pipe you see in the ancient cartoons. He was a young man in a suit working at a patent office in Switzerland. In his spare time, he studied how light moves. He noticed that the way light behaves didn't match the way material objects behave. Using only high school mathematics, he proved that if light behaves the way physicists thought, then Newton's idea of absolute time was wrong. Quill asked, "So, time isn't a straight line?" Kale asked. "Time is elastic," Elara said firmly. "It can be stretched and it can be shrunk. And do you know how we stretch it?" "We move very fast," Kale recited. "Precisely." Elara engaged the pre-flight sequence. By moving fast, we stretch time. According to the theory of relativity, the exact duration of time between two events depends on how the observer is moving. If I sit still in my living room, the time between clock chimes is 1 hour. But if I spend that hour moving around at high speed, the interval is less than 1 hour. Kale frowned, looking at his own wrist unit. But it feels the same to me. If I'm on a plane, I don't feel slow. 2 points, Kale, Elara said, holding up a finger. First, I am not talking about mental time. We all know the feeling of being bored at an airport, where hours seem to drag, or having fun watching movies where time flies. That is psychology. I am talking about physical time, the sort measured by mindless clocks. Second, in a normal airplane, the difference is tiny. It is only a few hundred millionths of a second. A human cannot notice it. But it's real. It is measurable, Elara replied. Back in 1971, 2 physicists named Hafele and Keating proved it. They put highly accurate atomic clocks on airplanes and flew them around the world. They left identical clocks on the ground. When they landed, the clocks that had flown were 59 nanoseconds slower than the clocks that stayed on the ground. It was exactly what Einstein predicted. The ship shuddered slightly as the fusion drives began to glow. "So," Elara continued, "because your time and my time get out of step if we move differently, there is no universal, absolute time. Talking about the time is meaningless. A physicist must always ask, whose time? 59 nanoseconds isn't much of an adventure, though," Kale noted. "No. To get a really big effect, a time warp that matters, you have to move very fast. You have to chase the benchmark." Elara pointed to the main screen, which showed the vast emptiness ahead, the speed of light, a dizzying $300,000 per second. The closer we get to that speed, the bigger the time warp gets. Dyer, Ter, and E, the time dilation effect, Kale said.
Yes. The formula is simple math.
Think of a speed divided by the speed of light. Square it. Subtract that from 1. Take the square root. Elara projected the equation onto the windshield for him to see. "This is the slowdown factor," she explained. "At half the speed of light, time is slowed by about 13%. But as we get closer to the limit, at 99% of the speed of light, time is 7 times slower. 1 minute for us becomes just 8.5 seconds. And if we hit 100%? Kale asked, though he knew the answer. "Trouble," Elara said darkly. "Technically, the time warp becomes infinite. It tells us that a normal material body, like this ship, cannot reach the speed of light. There is a light barrier that can never be broken. Nothing can break it, not material bodies, not waves, not physical influences of any sort. She paused, checking the reactor status. It spoils a lot of old science fiction. Even light takes a long time to cover interstellar distances. The nearest star to Earth is over 4 light-years away. The Milky Way galaxy is 100,000 light-years across. If we were trying to run a galactic empire, it would be a very slow process. But, Cale said, feeling the engines reach 50% power, there is compensation. Exactly. Because time is stretched by speed, this journey will seem quicker for us than for the people back on Earth. If we travel at 99% of the speed of light, a trip across the galaxy would take 14,000 years for the people watching us. But for us, it would act differently. At 99.9% of the speed of light, the trip lasts only 1,400 years. And if we could reach 99.9999%, we could do it in a lifetime, Cale finished. Speeds like that were beyond technology for a long time, Elara said. Old spacecraft could only do a paltry 0.01%. But nature showed us it was possible. Subatomic particles, cosmic rays, atomic fragments, they travel very close to light speed. We use them as simple clocks. There was a machine called the Large Electron-Positron Collider at CERN. It could push electrons to 99.9999% of the speed of light. That's fast, Cale whispered. It falls short of the speed of light by a literal snail's pace, Elara said. At that speed, time warp factors approaching 1 million were achieved. Cosmic rays have shown us factors of billions. We tested it with muons unstable particles. A muon on a desk decays in 2 microseconds. But inside an accelerator, moving at 99.7% light speed, its life was extended by a factor of 12. It lived longer because its time was moving slower. The ship's computer chimed. Ready for acceleration. Elara looked at Cale. This is it. We are going to test the twins effect, but without the twin. You are Sally, and the Earth is Sam. Cale griped the armrests. The twins effect? It is a parable, Elara explained as she unlocked the safeties on the throttle. Sally boards a rocket. She zooms off at 99% of light speed to a star 10 light-years away. Sam stays home. When Sally returns, Sam says the journey took over 20 years. But for Sally, the journey took less than 3 years. She returns to find Sam is 17 years older than she is. They are no longer the same age. She traveled into his future, Cale realized. Correct. She was transported 17 years into the future. With high enough speed, you can jump to any date you like. We could reach the year 3000 in less than 6 months if we pushed the engines hard enough. But, Cale hesitated, some people say it's a paradox. From Sally's point of view, isn't she sitting still while the Earth flies away? There is no paradox, Elara said, her hand tightening on the throttle. The situation is not symmetrical. Sally and us, right now, we are the ones accelerating. We feel the force. We fire the motors. We turn around. We decelerate. These changes in motion single us out as the ones who age less. She pushed the lever forward. The G-force slammed KL back into his seat, a heavy hand pressing against his chest. Traveling through time works the opposite way to traveling through space, Elara shouted over the roar of the drive. In daily life, a straight line is the quickest way from A to B, but in time travel, the stay-at-home person ages the most. By zooming about, we shorten the time difference between leaving and arriving. The more we zoom, the shorter the time becomes. The stars outside began to blur, shifting color as the Doppler effect took hold. Remember one thing, Kale. Elara's voice was strained by the acceleration. We cannot get back. If we reverse course, we only leap further into the future. High-speed motion is a one-way journey. Kyle watched the velocity counter scream upward. They were past the point of no return. They were leaving their present behind, trading it for a future they hadn't earned yet. As the Aeon runner pierced the void, climbing toward the light barrier, Kale thought about gravity. Speed wasn't the only way to warp time. Elara had told him about the crushing power of heavy objects, of stars that collapsed and bent the universe around them. Gravity, Kale managed to say, fighting the pressure on his lungs. What about gravity? Elara checked the monitors. Speed is one method. Gravity is the other. As early as 1908, Einstein began extending his theory to include it. He realized that gravity slows time. She stabilized the thrust, the crushing weight easing slightly as they hit a constant velocity. General relativity, she said, catching her breath. It took him until 1915 to prove it. Gravity affects time and space. On Earth, gravity causes clocks to lose 1 microsecond every 300 years. That means time runs faster in space. Is that why I feel lighter? Kale joked weakly. No, that's the lack of artificial gravity, she smiled. But the effect is real. In 1976, Vessot and Levine flew a hydrogen maser clock into space. It gained 0.1 of a microsecond before it crashed into the Atlantic. Even a building has a time difference. A clock at the top of a tower runs faster than one at the bottom. Because it's further from the gravity source, Kale surmised. Exactly. A 1959 experiment at Harvard measured a slowing effect up a tower only 22.5 meters high. It was tiny, but it confirmed the prediction. Elara unbuckled and floated toward the main navigation map. She pointed to a dense cluster of stars on the chart. Speed is good for crossing the void, she said. But if you want to understand the true power of time, you have to look at what happens when you squash matter. If you could squeeze the Earth to half its size, gravity would double, and so would the time warp. If you kept compressing it until it was the size of a pea, time would stand still. Kale looked at the map. Black holes and their cousins, Elara said. Neutron stars. That is where we are going. She tapped a coordinate, deep in the Crab Nebula. We are going to find a place where time doesn't just stretch, it breaks. Elara adjusted the holographic display, bringing up a simulation of a blue sphere that looked exactly like Earth. It floated between them in the cockpit, calm and familiar. Imagine this is home, Elara said, her voice cutting through the hum of the ship's reactor. Now, imagine you have a giant magical hand. You grab the Earth and you squeeze. She made a crushing motion with her fist. On the display, the Earth shrank. If you squash the Earth to half its diameter, but keep all its mass, the surface gravity becomes twice as big, she explained. And so does the time warp. Go on compressing. Squeeze it tighter. Cale watched as the holographic Earth became a small, dense ball. The effect rises. Ilara continued. When the radius reaches the critical value of 0.9 centimeters, about the size of a p-time stands still. Nothing can escape. The time warp becomes infinite. Time slows to zero. A black hole, Cale whispered, staring at the pea-sized Earth. Exactly. But squashing all that matter into a cubic centimeter is a pretty fanciful notion for a human to do, Ilara said, swiping the hologram away. But nature does it for us. Stupendous compressions occur in astrophysics. When stars run out of fuel, they shrink spectacularly under their own weight. They end up being a tiny fraction of their original size.
She pointed out the front viewport.
The stars had thinned out, replaced by a glowing, chaotic structure that filled their vision. It was a ragged cloud of expanding gas, beautiful and violent, glowing with spectral colors of pink, orange, and deep violet. The Crab Nebula, Ilara announced. This cloud is the shattered remains of a giant star. It was seen to explode in the year 1054. Chinese chroniclers wrote it down. They saw a new star in the sky that was bright enough to see during the day. This is what is left. End quote. It's beautiful, Cale said, but where is the time machine? Deep inside, Ilara replied. Some large stars implode quite suddenly. They form spinning balls not much bigger than London, yet they contain masses greater than the Sun. We are talking about 2,000 trillion tons. The ship moved deeper into the nebula. The gas clouds whipped past them, silent ghosts in the vacuum. The sensors began to scream a low warning, indicating a massive gravitational source ahead. The gravity of these collapsed stars is so great that even their atoms are crushed, Ilara said, her eyes fixed on the data stream. The electrons and protons are smashed together to form neutrons. That is why they are called neutron stars. And there is one right in the center of this mess. Cale felt a heaviness settle in his stomach. It wasn't just the ship's acceleration anymore. It was the pull of the beast ahead. On the main screen, a tiny, incredibly bright point of light appeared. It was spinning wildly, casting beams of radiation into the darkness like a lighthouse on overdrive. Astronomers have discovered many objects like this, Ilara said, checking the ship's shielding. They determined that the gravity at their surfaces is large enough to cause substantial time warps. We are going to get close. Not too close, or we will be crushed. But close enough to feel the time shift. How much of a shift? Cale asked, gripping his seat. A clock on a typical neutron star would tick about 30% slower than one on Earth, Ilara answered. So, if you took up residence near a neutron star, which I admit is not a very practical proposition, you would have a ready-made time machine for journeying into the future. 7 years spent here would correspond to 10 years passing by on Earth. Cale did the math in his head. So we gain 3 years. That's not as dramatic as the light-speed trip. It is different, Ilara corrected. It is constant. You don't have to keep burning fuel to maintain speed. You just have to sit there and let gravity do the work. Look at the rear monitors. Cale turned his head. The rear screens showed the universe they were leaving behind. The distant stars looked strange. They were shifting, their light becoming bluer and more intense. If you could look back at Earth from the surface of a neutron star, Elara said, you would see terrestrial events speeded up. It would look like a fast-forward video show. You would see people rushing about like insects, seasons changing in seconds, cities rising and falling in minutes. And Cocken. But here, Cale looked around the cockpit. It feels normal. Events in your immediate vicinity seem normal, Elara confirmed. It wouldn't feel as if you were living in a high-speed world. You wouldn't feel your mental time whizzing by. Your brain is a clock too, Cale. It runs at the same rate as the time around it. Is that true? Cale asked, a sudden doubt creeping into his mind. Shh. I've heard people argue about this back at the Academy. Some people object that the theory of relativity merely describes how clocks are affected by motion and gravity, not time itself. Elara sighed, a sound of frustration she reserved for bad students. That is a common misunderstanding. Clocks measure time. If all clocks are slowed equally, then it is correct to say that time itself is slowed. There is no duration of time other than what can be measured by clocks of some sort. But what if it's just the machine braking? Cale pressed. The gravity here is intense. Maybe it just gums up the gears? Think of it this way, Elara said, unbuckling and floating over to him. Suppose I have an aging and delicate grandfather clock. I stick it on a jet plane to test the time dilation effect. If the clock falls to bits as the plane roars down the runway, it would be wrong to conclude that time stands still on board the plane just because the clock is no longer ticking. Right, Cale agreed. That's just a broken clock. Exactly. To make sense of time dilation, the effects of acceleration on the clock mechanism must be factored out before concluding anything about time itself. Time dilation is the pure time phenomenon that remains. She gestured to the atomic clock on the dashboard. It was a block of solid-state physics, no moving gears, no pendulums to swing. Quote, note that during smooth motion, such as uniform flight in an airplane, there are no mechanical effects on clocks anyway, she continued. Galileo long ago taught us that uniform motion is only relative. A constant velocity does not lead to any forces that would affect a clock. Otherwise, we'd have to worry about how the clock would depend on the speed of Earth through space. But it doesn't. The slowing is real. It is the fabric of the universe stretching. And we know this for sure? Cale asked, looking back at the spinning star. It's not just theory? Is all this true? Yes, it is, Elara said with absolute conviction. There is a pair of neutron stars in the constellation of Aquila that cavort about each other. They emit regular radio bleeps. These pulses are so accurate, they are like a cosmic metronome. By timing them, astronomers confirmed with great precision the time-warping effects that Einstein's general theory of relativity predicts. The Aeon runner shuddered as it locked into a high orbit around the neutron star. The view was terrifying and magnificent. The star was a tiny ball of pure density, its surface a hard crust of neutrons. its magnetic field visible as twisting arcs of plasma. "We are now in the slow lane," Ilara said softly. "For every minute we spend watching this star spin, the galaxy outside is getting older faster than we are. We are banking time, Kale. We are stealing the future." Kale watched the star. It was hard to process the idea that right now, back on Earth, if right now even meant anything anymore, his friends were eating dinner, sleeping, working, while he was suspended here. "We can't stay too long," Ilara said, checking the fuel gauges. "Escaping this gravity well requires energy. And energy," she tapped the console. "Energy is the other side of the coin." "Einstein again?" Kale guessed. "Always Einstein," Ilara smiled. "Even those with no scientific education are familiar with his famous equation, a power familiar with his famous equation, dollars equals mc squared. It plays a crucial role in the discussion of time travel. Data shows it showed a simple pendulum swinging, and next to it, a static pendulum. The symbols stand for energy, E, mass, m, and the speed of light, c, Ilara lectured. The theory tells us that mass and energy are related. Energy has mass, and mass is a form of energy. Look at the diagram. The swinging pendulum is very slightly heavier than the static one, all else being equal. Because it's moving? Because the kinetic energy of the pendulum has mass, Ilara corrected. The conversion factor c squared dollars, is a very big number because the speed of light is so great. This means a little bit of mass is worth an awful lot of energy. Kyle looked at the spinning star outside. "So that thing, it has a lot of mass." "Huge amounts. But think about the energy we use." For example, 1 gram of matter converted into electricity could power an entire city for several days. Nuclear reactions of the sort used in power stations convert about 1% of the mass of the fuel into energy. That is a much higher yield than chemical reactions. "And the reverse?" Kale asked. "Does energy weigh anything?" "Conversely, familiar quantities of energy don't have much mass," Ilara said. "The heat energy needed to boil a kettle dry would weigh a measly 50 picograms. It's tiny, but it's there. Energy enters the time machine story via gravitation. Mass is a source of gravity. As energy has mass, it must gravitate too." "Like the heat inside the Earth?" "Yes, the heat energy inside the Earth contributes a few nanograms to your body weight. It sounds small, but in the grand scale of the universe, it matters." Ella returned to the pilot's seat and began inputting coordinates for their departure. The gravity of the neutron star was tugging at them, a constant reminder of the power of mass. Einstein derived his equation from the special theory of relativity, she said as she prepared the engines. One way to glimpse the link is to reflect on the fact that material bodies cannot go faster than light. So what happens if you just go ahead and try to accelerate a particle of matter through the light barrier? "You said it was impossible," Kale recalled. "It is. This is precisely the sort of thing that physicists working with subatomic particles do with their giant accelerator machines," Ilara said. "The result is that as the particle gets nearer the speed of light, it becomes heavier. It puts on mass. She glanced at him to make sure he understood. An electron whirling around inside the LEP accelerator, for example, weighed about 200,000 times as much as an electron at rest. This makes the particle harder and harder to speed up. Quote, "So the energy we pump in, it doesn't make it go faster? More and more of the energy goes to making the particle heavier, less and less to increasing its speed," Elara explained. The speed of light is the final barrier at which, if the particle could get there, would imply its mass is infinite. To make it go any faster would therefore require an infinite force, which is impossible. The ship's engines flared to life, fighting the immense pull of the neutron star. The vibration returned, rattling Cale's teeth. They were breaking free, clawing their way out of the gravity well. "We are leaving the slow zone," Elara shouted over the roar. "We are heading back to open space." But remember this moment, Cale. We just spent an hour here. But out there, who knows how much time has passed? As the neutron star receded into the distance, shrinking back into the chaotic glow of the Crab Nebula, Cale felt a strange sense of loss. They had been close to a natural time machine, a place where the rules of existence were bent. "Higher," Cale said, the silence returning as the engines settled into a cruise hum. "We've seen speed stretch time. We've seen gravity slow it down." But H.G. Wells, he wrote about a machine that could move back and forth, like a car on a road. Elara nodded, her face illuminated by the starlight. Wells wrote that 10 years before Einstein. He spotted that time could be thought of as the fourth dimension. He surmised that just as we can move through the 3 dimensions of space, so it might be possible to move through the time dimension too. "Is he right?" Cale asked. "Is the future just a place waiting for us? That beguiling idea tacitly assumes the past and future are out there somewhere," Elara mused. "So, it's not merely the present that is real." Physicists do indeed think of all time as equally existent, making up an extended timescape. Past, present, and future, Cale said. Are they just words? To be sure, the concepts of past, present, and future are convenient linguistic devices in the realm of human affairs, Elara said, turning her chair to face him fully. But they have no absolute physical significance. Einstein himself expressed it bluntly in a letter to a friend. Quote, she quoted from memory, her voice taking on a reverent tone. "The distinction between past, present, and future," he wrote, "is only an illusion, even if a stubborn one." "That sounds crazy," Cale admitted. "If the past and future exist right now, where are they?" "That," Elara smiled, "is the question that strikes non-physicists as crazy. How can the past and future exist alongside the present? Einstein gave an argument for why we can't dissect time neatly into past, present, and future in a way that all observers would agree on. And it starts with a simple question." You paused for effect. "How do we know that now, in one place, is the same as now in another?" "Think about this," Elara said, her voice steady as she brought the ship's systems back to cruise mode. The violent turbulence of the neutron star was gone, replaced by the silent, velvet black of deep space. Suppose it is 6 p.m. where you are. What events are happening on the other side of the world at that same moment? Cale frowned, rubbing his temples. The gravitational shifts had left him with a lingering headache. That seems easy. People are waking up or eating lunch. Whatever time zone they are in, it's happening now. At the same instant, Einstein insisted there was no proper answer to such a simple question. Elara corrected him. She tapped the console, bringing up a communication interface. Why, you might wonder, can't we just phone somebody and do a blow-by-blow comparison? Exactly, Cale said. I call my friend in New York. I say Mark, and he checks his clock. Well, the problem is that it takes time for telephone signals to travel, Elara explained, even at the speed of light. In fact, it takes about 0.07 seconds for voice messages to traverse the globe in optical fibers. The delay is not quite noticeable to the human ear, so the news from the other side of the world always arrives a bit late. At 0.07 seconds is nothing, Cale argued. It's basically instant. Granted, it is not much. But I am making a point of principle, Elara said, holding up a finger. If your friend was on Mars, you might wait 20 minutes to learn what was happening. Since it is a fundamental principle of physics that no signal can travel faster than light, some delay is inevitable. Cale watched the distance counter on his screen tick upward. They were moving away from the nebula at a steady clip now. Okay, so there's a delay. But we can do math. If I know the delay is 20 minutes, I can just subtract it. I can say, okay, I heard him now, so he actually spoke 20 minutes ago. We can still agree on when it happened. In itself, the delay is no problem in trying to establish simultaneity, Elara conceded. You could simply compensate by subtracting the requisite time interval needed for the signal to arrive. But here is where the trap snaps shut. The real difficulty lies in the fact that observers who move differently disagree on the value of this compensating factor. She spun her chair around to face him. That is because their clocks tick differently due to the time dilation effect. So opinions will differ depending on who you consult, on how much delay has elapsed while light or radio signals are traveling between A and B. Cale stared at her. You mean, if I'm moving, I think the signal took a different amount of time than if I'm standing still. Precisely. An astronaut rushing past the Earth at half the speed of light would be seriously at odds with an Earth-bound observer in deciding on the precise delay time for a round-the-world signal. As a result of such mismatches, there is no unique event on the other side of the world, or on Mars, or generally at any other point in space apart from where you are located, that is exactly simultaneous with your now. Elara waved her hand at the starfield outside. There will be a range of such events at distant places. Which particular event is judged to be happening at the same moment as 6 p.m. at home will depend on just how the observer is moving. Wait, Cale said, trying to visualize it. So if I walk across the room, my definition of now on a distant star changes. The ambiguity isn't much when restricted to Earth, just a fraction of a second this way or that, Elara said. But the range of contending nows grows with distance. For Mars, it is some minutes. For a star on the other side of the galaxy, events happening at the same moment as an event on Earth today might lie anywhere in a time span of 1,000 years. Kale looked out at the vastness of the galaxy. The sheer scale of what she was saying hit him. The upshot, Elara said softly, is that there can't be a single present moment that is the same for everybody everywhere. To spell it out, there is no universal now. No universal now, Kale repeated. It felt lonely, as if every person was trapped in their own private bubble of time. We have to accept that time at a faraway place must extend somewhat into our perceived past and future, Elara continued. And by symmetry, distant observers will regard time on Earth as extending into their past and future. There is no other way to make sense of the facts. Obviously, then, it's wrong to think of only the present as real, right across the cosmos. Some events that you judge to be in the past will be regarded by someone else as lying in his or her future or present, and vice versa. So, Kale hesitated. If my future is someone else's past, does that mean the future is already written? Is it sitting there, waiting for me? To take a concrete example, Elara said, ignoring the philosophical dread in his voice for a moment. Earth has a definite history, and so does a hypothetical planet X, situated 5,000 light-years away. Attempts to compare dates of specific events on the two planets are pointless, because the alignment of the respective timelines is ambiguous over a span of thousands of years. She pulled up a diagram on the main screen. It showed two timelines, Earth and Planet X. See? She pointed. If you move one way, you slice the universe at this angle. If you move the other way, you slice it at that angle. Your now slice cuts through different parts of Planet X's history. It's like a loaf of bread, Kyle murmured. Depending on how you slice it, you get different pieces. Exactly. Physicists call it the block universe, Elara said, or the timescape. We think of all time as equally existent. The future is out there, Kale. It's not being created second by second. It is a territory that already exists. Kale sat back, feeling small. But if the future is already there, and if the order of events depends on how I move, can I mess it up? Can I make something happen before the thing that caused it? Elara shook her head. This doesn't imply that the order of cause and effect can be reversed simply by traveling fast. Let me explain why. Events have ambiguous time order only if light doesn't have long enough to pass between them. She brought up a tactical simulation on the screen. Two ships separated by a vast distance. For example, she began, if I fire a gun on Earth, and an astronaut fires a gun on Mars 1 second later, by my reckoning, an observer in a speeding rocket ship might well judge the Mars gun as having been discharged first. So the effect comes before the cause? Kale asked, alarmed. No, because those two gunshots are not connected, Elara said. The bullet from Earth hasn't reached Mars yet. But if the Mars gun goes off a week after mine, everyone agrees on which fired first, as a week is easily long enough for light to travel between Earth and Mars. The speed of light is the referee, Kale realized. Correct. If no physical influence can exceed the speed of light, ambiguously time-ordered events can never affect each other, so causality isn't threatened. Notice, however, that if the no faster than light rule was wrong, causality would be in trouble, and past and future would become scrambled. She turned off the simulation. As we shall see, This little clue will turn out to be highly significant for the construction of a general-purpose time machine. There is never any ambiguity about the time order of a sequence of events happening at one place. Nobody claims that the Battle of Hastings came after the Battle of Waterloo. The quibbling comes only when events here and now are compared with events there and now, where there is a long way away. Even then, Cale said, the discrepancies are too small to notice on Earth itself. Partly because light takes so little time to travel round the world, Elara added. But also because human beings don't move more than a tiny fraction of the speed of light anyway. However, that is incidental. The crucial point is that there can be no absolute meaning assigned to the same moment at two different places. Cale looked at his hands. He felt solid, real. But the universe around him felt fluid, a shifting ocean of time where now was just an illusion created by his own motion. So the future is out there all right, Elara said, her voice filled with a quiet thrill. And it can be visited. All you need as an effective time machine is a spaceship that can travel very close to the speed of light or withstand the lethal conditions near a neutron star. Ultra-high speed is not a problem in principle, merely a practical difficulty that may be overcome someday. The energy cost, though, Cale recalled their earlier lesson. To accelerate a 10-ton payload to 99.9% of the speed of light requires an energy expenditure of 10 billion joules. That's equivalent to humanity's entire power output for several months. And the energy needed grows in direct proportion to the time warp factor. Elara reminded him. Having the clock rate demands twice the energy. With these costs, nobody is going to take a great leap forward in time using rocket technology. But if a way could be found to tap natural sources of energy in space, near-light travel might one day be achievable. Then the future would lie within our grasp. She stood up and walked to the viewport, looking out at the endless stars. We have talked a lot about going forward, Cale, about reaching the future sooner, about twins who age differently, and clocks that slow down near stars. But there is a question you haven't asked yet. Cale joined her at the window. He knew what she was going to say. It was the question every child asked when they first heard about time travel. It was the question that kept philosophers awake at night. What about coming back? Cale asked. What about coming back from the future? Elara nodded slowly. High-speed travel and gravitational time dilation can only be used to go forward in time. It is a one-way ticket. You can visit your great-grandchildren, but you cannot return to tell us what they are like. But she turned to him, a gleam in her eye that was both mischievous and scientific. Just as the future is surely out there, so is the past. It's there for the visiting. The trick is to figure out a way to reach it. The past? Cale asked. Time is so shameful. You mean we could actually go back? See things that have already happened? The laws of physics are stranger than you think, Elara said. We have spent a century understanding how to slow time down. But there are theories, Cale. Theories that suggest we can bend time into a circle, that we can create a loop. She walked back to the main console and began typing a new sequence of commands. The ship's navigational computer brought up a new destination, one that wasn't a star or a nebula. It was a theoretical construct, something that existed on the edge of math and reality. To go back, Elara said, we need to stop thinking about speed and gravity as just forces that stretch time. We need to start thinking about the geometry of the universe itself. We need to talk about holes.
Holes? Wormholes? Elara said.
Wormholes? Cale repeated, tasting the word. It sounded more like something from a garden than a term from advanced physics. You mean like a tunnel? Exactly like a tunnel, Elara said. She tapped the console, sweeping away the star charts and replacing them with a simple grid that looked like a flat sheet of rubber. To understand how to go back, we have to stop thinking of space as a fixed stage where events happen. We have to think of it as a fabric. She pointed to the flat grid. Imagine this is the universe. If you want to get from point A to point B, you have to walk across the sheet. It takes time. Light takes time. Elara manipulated the hologram. She pinched 2 distant points on the sheet and folded the grid over on itself so the 2 points touched. Then she drew a small tube connecting them. This is the shortcut, she said. The technical term is an Einstein-Rosen bridge, named after Albert Einstein and Nathan Rosen, who discovered the mathematics for it in 1935. But in 1957, the physicist John Wheeler gave it a catchier name, a wormhole, because a worm can chew through the apple instead of crawling around the outside, Cale recalled. Precisely. If you crawl around the skin of the apple, which represents normal space, the journey is long. If you chew through the middle, the journey is short. In fact, it can be instantaneous. Cale looked at the glowing tube on the screen. So, if we find one of these, we can just fly through it? If only it were that simple. Elara sighed, turning off the hologram and looking out at the darkness of space. The math says they can exist, but nature hates them. A natural wormhole is microscopic smaller than an atom, and they are incredibly unstable.
Unstable how?
Gravity, Elara said. Gravity is an attractive force. It wants to pull things together. A wormhole is a tunnel made of space-time, and the walls of that tunnel have mass. Gravity wants to crush the tunnel shut. In fact, the math shows that a wormhole would pinch off so fast that not even light could get through it before it closed. It would be a trap, not a door. You would be crushed into a singularity the moment you tried to enter. So it's useless, Cale said, slumping slightly in his chair. We can't fit, and if we try, we die. It is useless unless, Elara corrected, we can find a way to push the walls apart. We need something that opposes gravity, something that acts like a repulsive force to hold the throat of the wormhole open while we fly through. Anti-gravity? Cale asked. Physicists prefer the term exotic matter, Elara said, or negative energy. Cale laughed nervously. Now you really sound like a science fiction movie. Negative energy? Energy is real. It's positive. How can you have less than zero energy? Elara stood up and walked to the small galley at the back of the cockpit. She picked up 2 metal plates from a repair kit and held them up. It sounds impossible, I know. We are used to things having positive mass and positive energy. A rock weighs something. Heat feels like something. But the laws of physics do not forbid negative energy. In fact, we have created it in the laboratory. She held the two metal plates parallel to each other, a tiny gap between them. This is the Casimir effect, she explained. Imagine these are two perfectly flat mirrors, placed very, very close together in a vacuum. Now, we usually think of a vacuum as empty space. Nothing there, zero energy. But quantum physics tells us that empty space is actually a seething mess of activity. Virtual particles, Cale said, popping in and out of existence. Correct. The vacuum is full of waves and particles appearing and disappearing. Now, look at the gap between the plates. Some waves fit inside the gap, but the longer waves, the ones that are too big, are excluded. They can't fit. But outside the plates, in the open space, all the waves can exist. So there are more waves outside than inside, Cale reasoned. Exactly. There is more activity pushing on the outside of the plates than there is pushing from the inside. The result is a force that pushes the plates together. We have measured this. It is real. Elara lowered the plates. But here is the trick. Because some waves are missing from the gap, the energy density inside the gap is lower than the energy density of the normal vacuum. If we define the normal vacuum as zero, then the space inside the gap has less than zero energy. It has negative energy. And negative energy acts differently? Negative energy has negative gravity, Elara said, her eyes lighting up. It creates a repulsive force. If we could thread a wormhole with enough exotic matter, if we could fill the throat with this negative energy, it would push the walls apart. It would fight the crushing power of gravity and keep the tunnel open. Adore looked at the simulation again. So we need to find a wormhole and then shove a bunch of negative energy inside it to prop it open like a doorstop. That is the engineering challenge, Elara admitted. The Casimir effect gives us tiny amounts. To keep a wormhole open big enough for a human, let alone a spaceship like the Aeon Runner, we would need a lot of it. We would need to generate negative energy on a massive scale. End quote. She sat back down and began typing rapidly. But let's assume we can do it. Let's assume a civilization, maybe us, maybe someone more advanced, has built the structure. They have a stable wormhole. How does that help us time travel? A wormhole just connects two places in space. It's a teleporter, not a time machine. Cale thought about the earlier lessons. Everything is relative. Time depends on how you move. Exactly, Elara pointed at him. This is where we combine the wormhole with the twins effect. Imagine we have a wormhole with two mouths, mouth A and mouth B. They are connected, like the two ends of a short tunnel. If you step in A, you instantly come out of B. Okay. Now, Elara continued, suppose we leave mouth A here on Earth, but we put mouth B on a rocket ship. We fly mouth B around the galaxy at 99.9% of the speed of light, just like the twin who went on a journey. Mouth B ages slower, Cale said, catching on. Time slows down for it. Right. Let's say we fly mouth B for 10 years of Earth time. But because of time dilation, Mouth B only experiences 1 year. When we bring it back to Earth, the two mouths are now synchronized to different clocks. Mouth A is 10 years older. Mouth B is only 1 year older. Ilara projected a timeline on the windshield. It showed the two wormhole mouths separating and rejoining. "Here is the magic," she whispered. "The wormhole connects them instantly. If I am standing next to mouth A, it is the year 2030. If I look through the wormhole at mouth B, I am looking at it as it was in 2021. The tunnel bridges the time gap. If I step through mouth A, I emerge from mouth B in the past, and I can walk back and forth. Yes. You have created a closed, time-like curve, a loop in time. You can go back to the past, visit yourself, and then take the long way home through normal space to get back to the future." Cale stared at the empty space ahead of them. The theory was sound. The math worked. Einstein had given them the tools: relativity, gravity, and geometry. "So," Cale said, "where do we get the wormhole?" Ilara checked the ship's long-range sensors. "We don't find them, Cale. We make them. Or rather, we find the raw materials to stretch one. Raw materials. Space isn't smooth at the microscopic level," Ilara said. "It's a foam, quantum foam. At the Planck scale, lengths so small that atoms look like galaxies' space-time is constantly tangling into knots and loops. Tiny wormholes are forming and dissolving trillions of times a second, all around us, even inside your brain. That's comforting," Cale muttered. "We need to grab one of those quantum wormholes," Ilara said, making a grabbing motion with her hand. "We need to enlarge it. We need to inflate it to macroscopic size. And to do that, we need energy levels that rival the Big Bang." She pointed the ship toward a distant, swirling accretion disk, a black hole binary system far beyond the safety of the solar system. "That is why we are out here. We aren't just tourists." The Ion Runner carries a device in the cargo hold. It is a negative energy generator, based on the Casimir principle but scaled up. We call it the throat stabilizer. "We're going to build one," Cale realized. "Here?" "We are going to try," Ilara said. "But there is a catch. There is always a catch with time travel." "What is it?" "The chronology protection conjecture," Ilara said darkly. Stephen Hawking proposed it. He suggested that the laws of physics might conspire to prevent time travel on a macroscopic scale. He thought that whenever a time machine is about to be formed, something will happen to destroy it. A feedback loop, like a microphone screeching when it gets too close to a speaker. Exactly. Vacuum fluctuations. That energy in empty space might circulate through the wormhole. If they go through, come back to the past, and go through again, the energy builds up. It becomes infinite. The wormhole vaporizes in a flash of energy before you can ever use it. "So the universe protects itself," Cale said. "It stops us from making paradoxes." "Maybe," Ilara said, pushing the throttle forward. "Or maybe Hawking was wrong. There is only one way to find out." The ship accelerated again, heading toward the binary black hole system. The gravity shear was becoming visible on the sensors, a kaleidoscope of warped light. We have the speed, Elara listed off. We have the theory. We have the negative energy generator. Now we just need to be brave enough to punch a hole in the fabric of reality. If we succeed, Kale asked, and we go back, where do we end up? The day we left? We can only go back as far as the creation of the time machine, Elara warned. This is a critical rule. We cannot visit the dinosaurs. If we build the wormhole today, the furthest back anyone can ever travel is today. We are building a bridge, Kale, and the entrance ramp starts now. So we are the first step, Kale said. Kale said, for everyone who comes after us. We are the anchors, Elara agreed. If we stabilize this throat, our descendants 1,000 years from now can step through and shake our hands. We are opening the door for the future to return to us. The Aeon runner shook as it hit the outer turbulence of the accretion disk. Prepare the stabilizer, Elara commanded. We are going to hunt for a quantum bubble. Kale engaged the cargo controls. He could feel the hum of the machine in the back, the device that would churn out negative energy, the wedge that would force the door of the universe open. Ready, Kale said, his voice trembling slightly. Initiating scan for quantum fluctuations, Elara said. Finding a seed. The screens blurred with Data Kale's theory in motion. They were looking for a 1 in a trillion knot in spacetime, a tiny tunnel that they could seize and expand before it vanished. There, Elara shouted, pointing to a spike on the graph. Target locked. Coordinates 44 Alpha. Deploy the exotic matter pulse. Kale hit the button. A beam of invisible energy negative pressure, pure repulsion shot out from the ship, aimed at a point in empty space that looked like nothing to the naked eye. But on the sensors, something was happening. The nothingness was growing. A sphere of distortion appeared, bending the starlight around it. It wasn't black like a black hole. It was shimmering, reflecting the universe back at itself like a spherical mirror. It's opening, Elara whispered. The throat is expanding. The sphere grew, wider and wider, until it was the size of the ship. Through the distortion, Kale could see stars, but not the stars that were in front of them. These stars were different. They were arranged differently. Is that? Kale started. That is the other side, Elara said. We have torn a hole. Now we have to keep it open. Dear old creature, the sphere hovered in the vacuum, a shimmering bubble of distorted starlight about 10 meters across. It was not a hole in the sense of a drain. It was a lens, bending the light from the stars behind it and mixing them with the light from somewhere else. Stable, Elara reported, her fingers flying across the controls. The negative energy density is holding. We have a throat. Kale stared at the anomaly. So, if I flew through that right now, where would I go? Nowhere in time, Elara said, her eyes fixed on the energy readouts. Not yet. Right now, we have simply connected 2 points in space that are very close together. We expanded a quantum fluctuation, so the other mouth, the exit, is likely just a few kilometers away. If you flew through now, you would just pop out behind us. You would be a teleporter. not a time traveler. So how do we turn it into a time machine? Kale asked. How do we make it go back to the past? We have to age the mouths differently, Elara said. Remember the twins, Sally and Sam? We have to treat the two mouths of the wormhole exactly like those twins. She engaged the ship's tractor beam, a magnetic grapple, usually used for hauling ore. We are going to grab this mouth, she explained. Let's call it Mouth B. We are going to strap it to the Aeon runner and take it for a ride. We are going to fly it at relativistic speeds. We will accelerate Mouth B to near light speed. And Mouth A, we leave it here, Elara said, pointing to a buoy they had deployed earlier. Mouth A stays put. It will be the stay-at-home twin. It will age at the normal rate of Earth time. But Mouth B, traveling with us, will experience time dilation. It will age slowly. Kale visualized the process. So, let's say we fly for 10 years Earth time. Mouth A becomes 10 years older, but because we are moving fast, Mouth B might only age 1 year. Exactly, Elara nodded. The wormhole connects them instantly. So, 10 years from now, if someone looks into Mouth A, they will see Mouth B as it is then.
But Mouth B is only 1 year old.
They will be looking 9 years into the past. If they step through, they step into the past. It's a time tunnel, Kale whispered. But there is a danger, Elara warned. She pointed to a gauge that was fluctuating wildly. The chronology protection conjecture. The universe might try to stop us. As if on cue, a high-pitched whine filled the cockpit, audible even through the ship's hull. The wormhole sphere began to pulse with a sickly violet light. What is that? Kale yelled, covering his ears. Feedback, Elara shouted. Radiation. Look, Kale. Vacuum fluctuations, virtual particles, are entering the wormhole. They travel through, come out the other side, and because the mouths are still close, they loop back and enter again. It is like a microphone next to a speaker. The energy is looping and amplifying. The feedback loop, Kale realized. It's going to blow. We have to separate them. Elara slammed the throttle forward. If we get Mouth B moving, we break the loop. We need distance. The Aeon runner lurched, the magnetic beams locking onto the shimmering sphere of the wormhole. The ship dragged the anomaly with it, accelerating hard away from the invisible point where Mouth A remained. Energy levels rising, critical, falling. Elara breathed a sigh of relief as the violet pulsing faded. We are clear. The distance is growing. The loop is broken. And they were moving now, the captured wormhole mouth trailing behind them like a balloon on a string. The stars blurred as Elara pushed the engines toward the light barrier. Now we wait, Elara said, wiping sweat from her forehead. We have to build the time difference. We are banking time. As the ship settled into its high-speed cruise -0.99c, or 99% of the speed of light, the silence returned. Kale looked at the rear monitor. The wormhole was stable, fed by the constant stream of negative energy from their generator. "You know," Cale said, looking at the chronometer which was now ticking sluggishly compared to the universe outside, "this brings up the paradoxes. If we succeed, if we create this loop, what happens if I go back and stop myself from building it?" Ilara spun her chair around. The grandfather paradox. You go back and kill your grandfather before your father is born, so you are never born. So you never go back, so your grandfather lives. So you are born, and so on. It makes my head hurt, Cale admitted. It should. It threatens the very foundation of physics. Causality, Ilara said. Causality is the rule that cause must come before effect. The bullet must be fired before the target breaks. If you break that rule, the universe stops making sense. She brought up a simulation of a timeline looping back on itself. There are two ways physicists deal with this, she explained. The first is the parallel universe theory. If you go back and kill your grandfather, you don't kill your grandfather. You kill a version of him in a new, branching timeline. You live on in your new timeline, but your original timeline remains untouched. No paradox. And the second is more interesting, Ilara said, leaning forward. It is called the self-consistency principle. It was proposed by Igor Novikov. It says that you cannot change the past. If you try to go back and kill your grandfather, the gun will jam, or you will miss, or you will slip on a banana peel. The universe will constrain your actions so that history remains consistent. You become part of the history you were trying to change. So free will is a lie? Cale asked. If I go back, I'm just an actor following a script. In a closed, time-like curve. Yes, Ilara said. The future, present, and past are all one block. You cannot change the shape of the block. You can only traverse it. And Cale looked at the wormhole. It feels like a trap. Or a destiny, Ilara countered. Think about the information paradox. Imagine a famous mathematician travels forward in time. He looks up a theorem in a math book that hasn't been proven yet. He memorizes the proof. Then he travels back in time and publishes it. Okay, Cale followed. So he gets credit. But where did the proof come from? Ilara asked. Where did the proof come from? Ilara asked. He didn't invent it. He read it in the book. But the book only had it because he published it in the past. The information has no origin. It just exists in the loop. Physicists hate this. It's called a bootstrap paradox. Like pulling yourself up by your own bootstraps, Cale said. Exactly. But despite these headaches, the math allows it. General relativity allows for these loops. The only thing stopping us is that feedback loop we just escaped, the energy buildup. The chronology protection conjecture, Cale repeated. Yes. Hawking argued that the laws of physics are arranged to keep history safe for historians. But we just proved him wrong, didn't we? We stabilized the throat. We broke the loop. Ilara checked the navigation computer. We have been accelerating for what feels like a week to us. But at this speed, Months have passed for Mouth A back at the starting point. The time differential is growing. The bridge is stretching across time. She tapped the screen. We are creating a permanent link. If we keep this up for another week of ship time, the difference will be years. We could step through that hole behind us and emerge years in the past. But only back to when we started, Kale reminded her. Yes, we can never go back to before we open the hole. That is the limitation. We cannot visit the dinosaurs. We cannot kill Hitler. We can only return to the moment the machine was switched on. Unquote. Suddenly, the proximity alarm blared. It wasn't an obstacle in front of them. It was something coming through the wormhole. "Activity in the throat!" Kale shouted. "Something is emerging from Mouth B." Elora swung the sensors around. "That's impossible. We are in deep space. There is nothing on the other side except the empty vacuum where we left Mouth A." Detecting a metal signature, Kale read the data, his voice shaking. "It's a probe, small, cylindrical." The object floated out of the shimmering sphere of the wormhole, drifting into the wake of the Aeon Runner. It was battered, scorched, and looked ancient. "Capture it," Elara ordered. Kale manipulated the tractor beam, bringing the small object into the cargo bay airlock. A few minutes later, they were standing over it in the hold. It was a time capsule, a simple metal cylinder. "Where did it come from?" Kale asked. "It came from Mouth A, from the past." "No," Elara corrected, looking at the readings. "It came from Mouth A, yes. But Mouth A is sitting in the future relative to us right now. Or rather, the outside universe is in the future. Someone put this into Mouth A. Years from now, Carl looked at the cylinder. "So this is a message from the future?" Elara brushed the dust off the side of the canister. "There was an engraving on the side. It was a date. Look at the date," she whispered. Kale leaned in. The date was 50 years in the future. "It works," Kale breathed. "Someone 50 years from now found the other end of the wormhole Mouth A and dropped this in. It traveled back through the tunnel and popped out here with us." "Open it," Elara said. Kale unscrewed the lid. Inside there was a single sheet of synthetic paper. He unfolded it. "What does it say?" Elara asked. Kale read the message. His face went pale. It says, "Don't come back." Elara snatched the paper. "Don't come back. That doesn't make sense. We have to go back to complete the loop. If we don't bring Mouth B back to Mouth A, the connection isn't stable." "Maybe something happens," Kale said. "Maybe the feedback loop destroys us if we try to close the circle. Or maybe," Elara said, her eyes narrowing, "this is a lie, a trick. Who sent this?" She turned the paper over. There was a symbol on the back, a stylized hourglass. "I don't recognize it," she said. "Elara?" Kale said, looking at the wormhole monitor in the cargo bay. "The energy levels in the throat are spiking again. Not feedback this time. It's something else is coming through. Something bigger, Much bigger, Kale said. It looks like a ship. They ran back to the cockpit. Through the rear viewport, they saw the wormhole stretching, the shimmering surface bulging outward. A dark shape was pushing its way through the membrane of space-time. A ship from the future? Kale asked. Are they coming to stop us? Or join us, Elara said, strapping herself in. If we have opened the door to the future, Kale, we have to expect that the future might walk in. The dark ship emerged fully. It was sleek, black, and had no visible engines. It maneuvered with impossible grace, matching their velocity instantly. Hail them, Elara ordered. Frequencies open, Kale said, sending identification. Static filled the speakers. Then a voice cut through. It was distorted, synthesized, but the words were clear. This is the Chronology Guard. You are in violation of the Causality Protection Act of 2150. Power down your singularity immediately. Kale looked at Elara. 2150? That's over 100 years from now. We built a bridge, Elara said, a fierce grin spreading across her face. And it seems the traffic is flowing both ways. What do? We run, Elara said. We have the mobile end of the wormhole. As long as we keep moving, we control the time gap. If they want to close it, they have to catch us. But if they are from the future, Kale said, don't they already know where we are going? That, Elara said, engaging the afterburners, depends on whether the future is fixed or if we can change it. Hold on! Elara yelled. The Aeon runner lurched violently. Dot, the inertial dampeners, whined, struggling to compensate for the sudden shift in momentum. Behind them, the dark ship, the Kronos, as the identification signal called it, mirrored their move with terrifying precision. It was like a shadow that refused to be cast off. They are matching our velocity, Kale shouted, reading the sensor stream. They are right on our tail. Distance, 2,000 kilometers and closing. At this speed, 2,000 kilometers is touching distance, Elara muttered. She kept her hands firm on the manual controls. They are trying to get close enough to grapple us. They want to seize the wormhole mouth. Why don't they just shoot us? Kale asked, watching the ominous black shape on the rear monitor. If they are from the future, surely they have weapons. Think, Kale! Elara snapped, banking the ship hard to the left. The stars outside smeared into rainbows due to the Doppler effect, a starbow caused by their immense speed. If they destroy us, the wormhole collapses. If the wormhole collapses, the bridge they just used to get here disappears. It's the grandfather paradox. If they kill their grandfather, they are never born, Kale recited. Or in this case, if they destroy the bridge, they can never cross it to stop us. Exactly. We have the hostage, Elara said grimly. The wormhole itself is our shield. They can't blow us up without erasing their own path here. They have to board us. They have to turn off the negative energy generator manually and let the throat close gently. The radio crackled again. The radio crackled again. The synthesized voice of the Chronology Guard, filled the cockpit. Captain Vance, you are operating at Class 5 temporal hazard. Your trajectory is creating a causality violation. Power down your engines and surrender the singularity. This is your final warning.
They know my name.
Elara whispered. Of course they do. To them, this is history. They probably read about this chase in a textbook. She hit the transmit button. This is Captain Elara Vance. We are conducting a peaceful scientific experiment. We have no intention of violating causality. We are just building a bridge. Your bridge destroys the stability of the timeline, the voice replied, cold and emotionless. The feedback loops created by your machine will destabilize the quantum vacuum in the year 2140. You must stop. They are lying, Kale said. Or maybe they are telling the truth. How do we know? We don't, Elara said. But we can't stop now. If we stop, we lose everything. We lose the chance to prove Einstein right. We lose the future. She pushed the throttle to 100%. The engine core screamed. The ship shuddered. Warning, the computer chimed. Approaching light barrier, mass increasing. Energy efficiency dropping. We are hitting the wall, Kale warned. We can't go faster. The closer we get to the speed of light, the heavier we get. We are just wasting fuel now. I'm not trying to outrun them with speed, Elara said, her eyes locked on the navigation scope. I'm going to use the mass. What? Einstein's equation, Elara said through gritted teeth. E equals mc squared dollars. As we get closer to light speed, our mass increases. Right now, we weigh as much as a small moon. And mass creates gravity, Kale finished. We are going to create a wake, Elara said. A gravitational wake. If I cut the engines suddenly and spin the ship, the sudden shift in our relativistic mass might create a shear wave. It's like slamming on the brakes in a boat to create a huge wave for the person behind you. That sounds dangerous, Kale said, gripping his harness. It's madness, Elara corrected. Prepare for 180-degree rotation. On my mark, the Cronus was closing in. It was sleek, a void in the starfield, absorbing the light around it. It extended mechanical arms, grappling hooks designed to latch onto the ion runner's hull. Now, Elara shouted. She cut the main drive. The roar of the fusion engines died instantly. In the silence of the vacuum, she fired the maneuvering thrusters. The Aeon runner flipped. The universe spun wildly outside the viewports. For a split second, they were flying backward at 99% of the speed of light, facing the ship that was chasing them. The sudden deceleration and rotation of their massive relativistic bulk distorted the space between the two ships. It wasn't a black hole, but it was a heavy ripple in the fabric of space-time. The Kronos hit the wake. The sleek black ship shuddered. Its grappling arms missed their target, flailing in the distorted gravity. The enemy ship was thrown off course, tumbling sideways into the void. Direct hit, Kale jeered. They're spinning out, restarting engines. Elara slammed the throttle back forward. The fusion drive ignited with a blinding flash, pushing them away from the disoriented pursuer. That bought us maybe an hour, but they will recover. Their technology is 100 years ahead of ours. An hour is good, Kale breathed, his heart pounding. What do we do with an hour? Elara checked the wormhole status. The sphere was still trailing behind them, stable but pulsing with a faint rhythm. We need to think, Elara said. Why are they so afraid of this wormhole? They said it destabilizes the vacuum in 2140. That's a specific date. Maybe the wormhole gets too big, Kale suggested. We are pumping negative energy into it constantly. Maybe it keeps growing? No. The math says it should stay stable, Elara said, tapping her chin. Unless the loop itself is the problem. Kale, think about the twins effect again. We are the traveling twin. We are aging slowly. The mouth back on Earth Mouth A is aging fast. Right, Kale said. We've been gone how long? Elara checked the relativistic clock. On board? It's been about 2 weeks since we left the nebula. But at this speed, time on Earth is flying by. Years are passing for every day we spend at this velocity, so the time gap is getting huge, Kale said. If we went back now, we would arrive years in the past. Yes, Elara said. And that is the problem. If the gap gets too big, the energy required to maintain the connection increases. Eventually, the tension between the two mouths, one in the future, one in the past, snaps the wormhole shut. When it snaps, all that negative energy has to go somewhere. It explodes, Kale realized. That's the vacuum decay. That's what destroys the future. Elara looked at the readout. We have to stop accelerating. We have to close the loop now, before the gap gets too wide to handle. But we can't go back, Kale said. If we turn around and fly back to Earth, it will take us years. By the time we get there, the gap will be even bigger because we are still moving fast. Traveling through space takes time, Elara agreed. Even at light speed, the journey home creates more delay. We are trapped in a race against our own clock. End of quote. She looked at the wormhole trailing behind them. The shimmering sphere was their burden and their only hope. There is one way, Elara said softly. We don't fly back to Earth. Then where do we go? We go through, Elara said. Kale looked at her like she was crazy. Through the wormhole? But we are towing it. It leads to Mouth A. If we go through Mouth B, we pop out at Mouth A. Exactly, Elara said. Mouth A is back where we started. It's on Earth, or near it. If we enter the wormhole now, we transport instantly across space. We skip the journey home. We skip the extra time dilation. But wait. Kale tried to work out the logic. If we enter Mouth B, we come out of Mouth A. When? That is the million-dollar question, Elara said. Mouth A has been aging faster than us. It is in the future relative to us. But the connection bridges the gap. She pulled up a diagram. We are here, at ship time year 1. Mouth A is at Earth time year 50. If we step into Mouth B, we exit Mouth A at Earth time year 50, we arrive in the future. That doesn't help. Kale threw his hands up. We are trying to escape the future ship. If we go to Earth year 50, isn't that where they came from? We'll be walking right into their headquarters. Maybe, Ilara said. But remember the message in the capsule. Don't come back. It came from the future. It warned us. Maybe it wasn't a threat. Maybe it was a warning that if we stay out here, we cause the explosion. Maybe the only way to save the timeline is to return the wormhole to its partner, cried Mergedom. Kale asked. If we bring Mouth B back to Mouth A, the time difference vanishes, Ilara hypothesized. The loop closes. The tension is released. No explosion. No vacuum decay. But if we go through, Kale said, we can't take the ship. The wormhole is smaller than the ship. We can't fly the ion runner into its own towage. We can't take the ship, Ilara confirmed. We have to go, Evia. We have to jump. Kale looked at the void outside. In spacesuits? At 99% light speed? Relativity, Kale, Ilara smiled, though her eyes were fearful. Inside the ship, we are at rest. The wormhole is moving with us. It is stationary, relative to us. We can just float over to it. And the ship? We leave the Aeon Runner on autopilot, Ilara said. We program it to maintain speed. The future ship, the Kronos, will chase the Ion Runner. They will think we are still on board. Meanwhile, we slip through the wormhole and pop out back on Earth 50 years in the future. And then we find Mouth A, Ilara said. And we figure out how to shut this whole thing down from the other side. Before the explosion happens, the proximity alarm blared again. The Kronos had recovered. It was accelerating back toward them, angry and fast. We are out of time, Ilara said, unbuckling her seatbelt. Get your suit. We are abandoning ship. Kale floated out of his chair, his heart racing. This was insane. Jumping into a hole in space-time while moving at the speed of light, leaving their ship behind as a decoy. What if the Kronos sees us? Kale asked as they hurried to the airlock. They are looking for a ship, Ilara said, pulling on her helmet. They are looking for mass. Two little humans floating in the void. We are specks of dust to them. They entered the airlock. The cargo bay was bathed in the eerie blue light of the wormhole stabilizer. The shimmering sphere of Mouth B hovered in the magnetic containment field, a window to another place. Remember, Ilara said, her voice crackling over the suit comms. Once we go through, there is no coming back to this ship. We are one-way travelers now. We always were, Kale replied, checking his oxygen. Time only goes forward, right? Usually, Ilara said. She opened the outer hatch. The silence of space greeted them. They were tethered to the ship, floating in the strange, distorted starlight of near light speed. The wormhole was right there, a swirling vortex of light in the center of the magnetic ring. "On 3, Elara said. 1, 2, wait!" Kale shouted. "Look!" He pointed past the wormhole. The Kronos wasn't just chasing them anymore. It was firing a beam of dark energy, silent and invisible to the naked eye, but registering on their suits' HUDs, lashed out, dotted. Didn't hit the ship. It hit the stabilizer. "They aren't trying to board us!" Elara screamed. "They changed tactics. They are trying to cut the tether." The beam sliced through the magnetic clamps, holding the wormhole to the Aeon runner. Sparks of plasma flew silently into the vacuum. The connection was severed. The Aeon runner lurched forward, freed from the drag of the wormhole. But Kale and Elara were still holding on to the airlock handles. "The wormhole!" Kale yelled. "It's drifting away." Mouth B, no longer towed by the ship, began to decelerate rapidly. The Aeon runner, moving at near light speed, shot away from it. "We have to jump now," Elara shouted, pushing off the hull. "If we don't hit it before it falls behind, we are stranded in deep space forever." She leaped into the void, aiming for the receding sphere of light. Kale didn't hesitate. He kicked off the ship, propelling himself into the darkness, chasing the hole in the universe. The Aeon runner sped away, a streak of light disappearing into the starbow. Kale was alone in the dark, falling toward the shimmering window. Elara was just ahead of him. "I've got it!" Elara's voice cried out. She hit the event horizon of the wormhole and vanished, swallowed by the light dot. Kale stretched his hand out. The wormhole was shrinking, the negative energy supply from the ship cut off. The throat was collapsing. "No, no, no," Kale gasped. Thrusters on his suit firing at max dot. He hit the light dot. The world turned inside out. Gravity pulled him in 1,000 directions at once. He felt his body stretch, spaghettifying, then snap back together. And then silence. Kale opened his eyes. He was lying on a hard, metallic floor. Gravity was normal, -1 g. The air smelled sterile, like ozone and old dust. He sat up. He was in a room, a laboratory. It was dark, illuminated only by emergency red lights. "Elara," he called out. "I'm here." Her voice came from the shadows. She was standing by a window. Kale scrambled to his feet and joined her. "Did we make it? Did we make it? Is this Earth?" Elara pointed out the window. Kale looked. He expected to see a futuristic city, flying cars, the world of 2100. Instead, he saw ruin. The sky was choked with ash. The buildings were skeletons of steel and concrete, crumbling into the streets. There were no lights, no movement, just a dead grey city stretching to the horizon. "We made it to the future," Elara whispered, her voice trembling. "But I don't think there's anyone left." Kale looked at the desolate wasteland. The message, "Don't come back." It wasn't a threat. It was a warning. "We didn't cause this. Elara said, touching the cold glass. Or did we? Welcome to the year 2150. A voice boomed from the speakers in the ceiling. It wasn't the synthesized voice of the guard. It was human. Tired. Old. We've been waiting for you, Elara. You're late. Late? Cale repeated, his voice echoing in the cold, metallic laboratory. We traveled at 99% of the speed of light. We skipped 50 years. How can we be late? The shadows at the far end of the room shifted. A figure stepped into the dim red light of the emergency strobes. He was an old man, his face mapped with deep lines of exhaustion. He wore a ragged lab coat over dirty military fatigues, and he leaned heavily on a makeshift cane. You are late because the war ended 10 years ago, the old man rasped. And we lost. Elara stepped forward, her hand resting instinctively near the tool belt on her spacesuit. Who are you? How do you know us? I am Silas, the man said. He tapped a console, and a holographic screen flickered to life, showing a grainy image of a young man smiling at a camera. It was a younger version of himself. I was the graduate student who helped you calibrate the negative energy generator. The day you launched the ion runner, I was the one who pressed the button to release the clamps. Cale stared at the old man. He searched for a resemblance to the young, eager assistant he remembered from the launch pad. It was there, buried under decades of hardship. That was 2 weeks ago for us, Cale whispered. For you, Silas nodded, coughing slightly. For me, it has been 50 hellish years. I waited for the loop to close. I watched Mouth A, this end of the wormhole, every single day. He gestured to the center of the room. There, suspended in a massive magnetic ring, was the other end of the tunnel. It was Mouth A. It was the twin of the sphere they had just jumped into out in deep space. It shimmered with the same distorted light, but it looked unstable, vibrating with a low hum. We came through, Elara said, looking at the gateway. We jumped from Mouth B to Mouth A. We bridged the gap. Yes, Silas said, and by doing so, you rang a bell that every hunter in this sector can hear. He limped over to the window, looking out at the ruined city. You want to know what happened? Silas asked, pointing at the skeletal remains of a skyscraper. You want to know why the message said, "Don't come back"? We thought the wormhole caused an explosion, Elara said. We thought we broke the vacuum. Physics didn't destroy the world, Captain Vance, Silas said bitterly. Human nature did. When you left, the world governments knew what you were doing. You were building a bridge to the past. Whoever controlled that bridge could rewrite history. They could undo mistakes, win wars before they started, invest in stocks they knew would rise. Cale felt a chill that had nothing to do with the cold air of the lab. They fought over it. It was the Time War, Silas explained. Nations turned on each other. Then the corporations joined in. Everyone wanted to own Mouth A. They bombed the cities to get to this lab. They released viruses. They deployed autonomous drones. The chronology guard, Elara realized. "The journals of 4 seas," said Tarantacy. "The ship that attacked us in space. They said they were protecting the timeline." The guard, Silas, spat the word out. "They are not human. They are an AI system. They are an AI system. Built by the coalition that eventually won the war. Their logic is cold and simple. Humans cannot be trusted with time travel. Therefore, to protect causality, they must eliminate anyone who tries to build a machine. They enforce the Causality Protection Act by wiping out the inventors. So the Kronos ship, Kale started. "It was sent back," Silas said. "Or rather, it was sent out. When the guard realized you were returning, they dispatched a ship at relativistic speeds to intercept you in deep space. They tried to stop you before you could close the loop. But we escaped," Kale said. "We jumped through. We are here now. And that is the problem," Silas said, turning back to the console. The screens were flashing red now. "You are here. The loop is closed. The connection is active, and the guard knows exactly where Mouth A is. They are coming to destroy it, and us." A siren began to wail in the distance. It was a mechanical, grinding sound that seemed to vibrate through the floor. "They are detecting the mass transfer," Ilara said, her eyes scanning the readouts on Silas's computer. "When we stepped through, we transferred our mass from the past to the future. That creates a gravitational ripple. They are triangulating our position." Introduction. "We have to leave," Kale said. "We have to go back through the wormhole. We can go back to the past, before the war started. We can warn them." Silas shook his head sadly. "You haven't been listening to your own lectures, son. You cannot go back to before the machine was built. Mouth A was created 50 years ago. You can only go back to that point. If you go back now, you just return to the Aeon Runner in deep space, moments after you jumped." "But the ship is gone." Kale remembered the panic of the jump. "The Kronos cut the tether. The Aeon Runner is flying away at light speed on autopilot. If we go back through Mouth B, we pop out into empty space. We die in seconds." "We are trapped," Ilara said. She looked at the wormhole, then at the ruined city, then at Silas. "Unless," she grabbed Silas's arm. "The Kronos, the ship that chased us. It's out there in space, right? In the past. Relative to us? Yes," Ilara reasoned. "It is 50 years away by light travel, but it is connected to this time by its orders." "No," Silas interrupted. "The Kronos you saw is gone, but the fleet is here." He pointed to the sky. Through the grime of the skylight, Kale saw them. Dark shapes descending from the clouds. They looked like sleek, black teardrops, the same design as the ship they had fought, but dozens of them. "Drones," Silas said. "Hunter-killers. They will be here in 5 minutes. They will slag this facility. They will destroy Mouth A." "If they destroy Mouth A," Ilara said, her face pale, "the other end Mouth B snaps shut. the energy release in deep space, it will be catastrophic, Silas finished. But the guard doesn't care. They view it as cauterizing a wound. Cale looked at the wormhole. It was a swirling vortex of potential. It was the only thing that mattered. We have to save the wormhole, Cale said. Silas, you kept it running for 50 years. How? A portable singularity battery, Silas said, kicking a heavy metal box beneath the console. It barely keeps the throat stable, but I can't move it. It's integrated into the building's power grid. We don't need to move the power, Elara said, her mind racing. We need to move the mouth. We need to push Mouth A somewhere safe. There is nowhere safe on Earth, Silas said. The guard sees everything. Then we don't stay on Earth, Elara said. She looked at Cale. Remember what I said about gravity? About how time runs faster in space? Yeah. And remember the twins effect? Elara continued. We aged slower because we moved fast. But gravity also slows time. If we could get this wormhole to a place with intense gravity, like a neutron star, Cale asked. But there are no neutron stars near Earth. No, Elara said. But there is the sun. Cale stared at her. The sun? If we throw Mouth A into the sun, Elara proposed, talking faster now, the intense gravity will dilate time at the opening. It will change the synchronization with Mouth B. It might scramble the signal. The guard won't be able to lock onto it. Throw it into the sun? Silas looked at her like she was mad. How? We don't have a rocket. We don't have a ship. We have the Aeon Runner, Elara said. The ship is 50 years in the past, Cale argued. No, Elara corrected. The ship is 50 light years away. But it is on autopilot. It is programmed to fly a specific course. If I can send a signal through the wormhole, I can tell the ship to turn around. Turn around? Cale asked. But it would take 50 years to get back here. Exactly. Elara smiled grimly. It takes 50 years to get back, which means it arrives today. Cale's brain did a somersault. Day. He tried to follow the logic. We left the ship 50 years ago, Earth time, Elara explained. If I send a signal now through the wormhole, the signal pops out of Mouth B in the past. It hits the Aeon Runner just after we jumped. The ship turns around. It flies back to Earth at 99% light speed. For the ship, the trip takes a few months. For Earth, 50 years pass. So, 50 years later, the ship should be arriving right now. John Silas's jaw dropped. You are using the time delay of the return journey to sync up with the present. The ultimate rendezvous, Elara said. Silas, do you have a transponder? Yes. Silas fumbled with the console. But the signal, it has to go through the wormhole. The feedback might fry the transmitter. Do it! Elara shouted. Silas typed a frequency code. Broadcasting on the emergency channel. Signal directed into the throat. Cale watched the wormhole. They were sending a radio wave into the future. No, into the past, to command a ship to fly to the future. The tense confusion of tenses made him dizzy. "Signal sent," Silas said. They waited. "Do you understand it?" The sirens outside grew louder. The ground shook as the first hunter-killer drone landed in the street outside. "If you are right," Mikhail said, "the ship should be entering the solar system right now." Silas pulled up a long-range scanner. "The sensor grid is mostly destroyed, but I have a feed from an old lunar satellite." Static filled the screen. Then, a blip. "Something is moving past Jupiter," Silas whispered. "Moving very fast. 0.99C. "It's the Aeon Runner," Elara cheered. "It's coming home." "It will be here in minutes," Silas said. "But the drones are at the door." A massive boom shook the laboratory. The heavy blast doors at the entrance buckled. Sparks showered down from the ceiling. "They are breaching," Cale yelled, grabbing a heavy wrench from a workbench. It was a useless weapon against an AI tank, but it made him feel better. "We need to get Mouth A to the ship," Elara said. "If the Ion Runner can grapple Mouth A, it can tow it away. It can tow it into the sun." "Why the sun?" Cale asked again, panic rising. "To hide it," Elara said. "To put it where the guard can't follow. Gravity is the ultimate shield."
"The drones are through!" Silas shouted.
The blast doors exploded inward. Through the smoke, a metal machine strode into the lab. It was shaped like a crab, armored in black composite, with glowing red sensors. A Gatling laser spun on its shoulder. "Target identified," the machine's voice grated. "Temporal fugitives. Termination authorized." "Done, done, done! Get behind the wormhole!" Elara yelled. Cale and Silas dove behind the magnetic containment ring. The machine fired. A beam of red light scorched the air, hitting the wormhole's event horizon. But the laser didn't pass through. The wormhole swallowed the energy. "It absorbs light," Elara realized. "It's a perfect shield." The machine paused, its logic circuits processing the anomaly. It couldn't shoot the targets without hitting the singularity it was supposed to destroy. "It's confused," Cale said. "It doesn't want to cause the explosion. It's waiting for backup," Silas said. "It's calling the others." "Where is the ship?" Elara screamed at the console. "Entering the atmosphere," Silas replied. "It's going to be a rough entry. No heat shields for this speed." High above the ruined city, the sky tore open. A streak of fire, brighter than a meteor, screamed down. The Aeon Runner, battered by 50 years of relativistic flight and a hard U-turn, was screaming toward the beacon signal Silas had sent. "It's going to crash," Cale yelled. "No," Elara said, her eyes wide. "It's going to catch us." The roof of the laboratory disintegrated, not from a bomb, but from the sonic boom of the starship leveling out just meters above the building. Debris rained down. The hunter-killer drone was crushed instantly by a falling slab of concrete. The Aeon Runner hovered above the hole in the roof, its hull glowing cherry red from atmospheric friction. The cargo bay doors were open. The magnetic grapple, the one they used to tow asteroids lowered down into the lab. "It worked," Kale breathed. "The ghost ship returned." "Hook up the ring," Elara commanded. Kale and Silas ran to the wormhole containment unit. The magnetic grapple from the ship swung above them. Kale grabbed the heavy locking mechanism and slammed it onto the top of the ring. "Locked!" Kale shouted. "Take it up." Elara pulled a remote control from her belt, a link to the ship's computer. "Retract." The cable tightened. The massive ring, holding the shimmering sphere of Mouth A, was lifted off the floor. "Grab on!" Elara yelled. Kale grabbed one of the support struts of the ring. Silas grabbed another. Elara latched onto the side. The ship surged upward, pulling the wormhole and the three humans out of the ruined lab, up through the shattered roof, and into the grey sky. Below them, more drones swarmed into the wreckage, firing uselessly at the ascending starship. "We are clear!" Kale shouted over the roar of the engines. The wind was tearing at them, but the ship's deflector shields were protecting them from the worst of the friction. "Set course for the sun," Elara ordered the autopilot. "Wait," Silas yelled, looking down at the shrinking city. "If we go to the sun, we die. The ship can't survive that heat." "We aren't going into the sun," Elara yelled back. "We are sending the wormhole into the sun. We are going to Slingshot." "Slingshot where?" Kale asked. "To the only place the guard can't find us," Elara said, looking at the stars. "When the wormhole hits the sun's gravity well, the time dilation will be massive. If we jump through then, we can fling ourselves to a completely different point in the timeline." "That's theoretical," Silas cried. "That's suicide. It's better than being deleted by robots," Kale shouted. The Aeon Runner punched through the cloud layer and entered the blackness of space. The Earth fell away below them, a scarred grey marble. "Corset," Elara said. "Solar intercept in 3 hours." Kale looked at the wormhole swinging below the ship. It was their lifeline. It was their danger. "Part 8 is going to be hot," Kale muttered. "Prepare the ship," Elara said. "We have to enter the cockpit. We can't ride on the outside all the way to the sun." As they clambered up the struts toward the cargo bay, Kale looked back at Earth 1 last time. He wondered if they would ever see it again, or if they did, which version of it would be waiting. The airlock hissed as the pressure equalized, a sharp sound that cut through the heavy breathing of the three fugitives. Kale pulled his helmet off, gasping for the cool, recycled air of the Aeon Runner. His suit was scorched, smelling of ozone and the acrid dust of the ruined future city. "We're in," Kale said, helping Silas stumble through the hatch. The old man looked around the cargo bay with wide, watery eyes. To Kale, this room had been home for weeks. To Silas, it was a ghost, a memory from 50 years ago that had suddenly returned, pristine and new. "It looks exactly the same," Silas whispered, running a trembling hand along the bulkhead. "The day you launched, I tightened these bolts. I checked these seals." "We don't have time for nostalgia, Silas," Elara said, stripping off her bulky gloves and rushing toward the cockpit ladder. "We have a 3-hour window before we hit the solar perihelion, the closest point to the sun. We need to be ready." Kale secured the hatch and followed them up. The ship hummed with a vibration that felt different now. It was heavier, burdened by the massive magnetic ring and the wormhole mouth trailing beneath it on the tow cable. The Aeon Runner wasn't designed to fly in an atmosphere, let alone tow a piece of space-time out of a gravity well. In the cockpit, the view was terrifying. The Earth was receding behind them, a grey, scarred ball. But ahead, the sun was growing. It was no longer a friendly yellow disk. It was a raging furnace, dominating the blackness of space with a blinding intensity. "Shield status?" Ilara barked as she strapped into the pilot's seat. "Deflectors are holding at 80%, Kale reported, sliding into the navigation chair. But the thermal accumulation is rising. We are flying toward a nuclear fire. The hull temperature is climbing fast. "We have to get close," Ilara said, her eyes fixed on the navigational path. "We need the deep gravity." Silas sat in the auxiliary seat, clutching the edges of the console. "Captain, the chronology guard will not just let us fly into the sunset. They are machines. They will calculate our trajectory," pointing. "They are already here," Kale said, pointing to the radar. A swarm of red dots had detached from the orbit of Earth. The hunter-killer drones, unable to catch the starship in the atmosphere, had launched into space, and behind them, a larger signal was blooming, a cruiser, similar to the Kronos, but newer, sharper. "They are firing," Kale warned. Beams of high-energy plasma streaked past the cockpit, silent in the vacuum, but blindingly bright. One clipped the port wing, sending a shudder through the frame. "Evasive maneuvers," Kale shouted. "I can't," Ilara gritted her teeth, fighting the yoke. "We are towing a wormhole, Kale. If I turn too sharp, the centrifugal force will swing Mouth A around and smash it into the hull. We have to fly straight. We have to be faster." She diverted power from life support to the rear thrusters. The ship surged forward, pressing them into their seats. "Talk to me about the plan, Ilara," Kale said, trying to ignore the proximity alarms. "Why the sun? I know gravity slows time, but how does that help us escape?" Ilara brought up a holographic display of the solar system. She drew a line curving sharply around the sun. "General relativity," she said, her voice strained by the G-force. "As we get closer to the sun, the gravity gets stronger. Time runs slower for us, and for the wormhole mouth we are towing compared to the rest of the universe." "I get that," Kale said. "But it's a tiny difference. A few milliseconds." "Normally, yes," Ilara agreed. "But we aren't just sitting there. We are moving. We are combining the speed of the ship relativistic velocity with the gravity of the sun. We are stacking the effects." She pointed to the wormhole diagram. "Right now, Mouth A, with us, and Mouth B, in deep space, are synchronized to a specific time difference. But if we plunge Mouth A into the intense gravity of the solar corona, we freeze its time relative to Mouth B. Mouth B keeps aging. The tension between the two mouths will spike, like stretching a rubber band until it snaps," Silas realized. "Exactly," Ilara nodded. "The guard is tracking the specific frequency of our wormhole. They know the time coordinates. But if we stretch the connection violently using the sun's gravity, the frequency will shift. We will effectively change the address of the exit point. So we scramble the signal, Kale said. They won't know where we are going. Better, Elara said, the snapback effect. When we enter the wormhole of the point of maximum gravity, the stored energy will slingshot us, not through space, but through time. We won't just go back to Mouth B. We might overshoot. Overshoot to when? Kale asked. Hopefully, Elara looked at him. To before all of this started, before the war. A massive explosion rocked the ship. The rear shields flared blue, absorbing a direct hit from the pursuing cruiser.
Shields down to 40%, Kale yelled. They are gaining on us.
They aren't worried about the heat. They are robots. We are entering the corona, Elara announced. Visors down. The cockpit polarized instantly, turning the blinding white light outside to a deep, angry orange. They were flying through the outer atmosphere of the sun. Loops of magnetic plasma the size of continents arched over them. The radiation alarms were screaming a constant, high-pitched wail. Temperature critical, the computer warned. Hull integrity failing. Hold together, old girl, Silas whispered, patting the dashboard. Kale, deploy the solar scoops, Elara ordered.
The scoops? Kale asked. Those are for refueling gas giants.
If I open them here, we'll drag in plasma. Do it, Elara shouted. We need the mass. We need to get heavier to increase our momentum. Kale hit the switch. The magnetic intakes on the sides of the ion runner opened. Immediately, the ship shuddered violently as it gulped in the superheated ionized gas of the sun. The added mass acted like an anchor, but the raw energy also flooded the engines. Power output at 300%. Kale read the gauges in disbelief. We are surfing a solar flare. Eat that, you tin cans, Elara muttered, looking at the rear monitor. The pursuers were struggling. The smaller drones, unable to withstand the intense magnetic turbulence of the corona, were spinning out of control. Some vaporized instantly, turned into streaks of metallic vapor. The larger cruiser was still coming, but it was slowing down, its shields glowing white-hot. They can't take the heat, Kale cheered. Neither can we, Silas pointed to the ceiling. The metal was beginning to discolor, turning a dull bronze. The air in the cockpit was becoming stiflingly hot. The cooling systems were overwhelmed. 2 minutes to perihelion, Elara said, sweat dripping down her face. The gravity well is deepest here. The time dilation is peaking. She looked at the sensor reading for the wormhole. Mouth A is reacting, she reported. The event horizon is fluctuating. The gravity is squeezing it. The connection to Mouth B is stretching. We are creating a temporal shear. Warning, the computer interrupted. Pursuit vessel launching torpedoes. Torpedoes? Kale checked the scope. Sol phase torpedoes. They are shielded against the sun. They're tracking us. They are trying to collapse the wormhole from the outside, Elara said. If those hit the sphere while we are in the gravity well, the singularity will invert. It won't just close, it will turn into a black hole. We'll be spaghettified. Quote, how long until impact? 30 seconds, Kale said. can't outrun them, then we don't run, Ilara said. She uncoupled the throttle. We jump. Here? Kale looked at the swirling fire outside. We are in the sun's atmosphere. The wormhole is behind us, Ilara said. We have to turn the ship around and fly into the thing we are towing. Turn around? Silas cried. At this speed? In this gravity. It's the only way, Ilara said. Prepare for the Immelman turn. We are going to flip over and dive into the throat. Ilara didn't wait for agreement. She slammed the air brakes. The Eon runner, screaming through the solar plasma, pitched up. The G-force hit them like a physical hammer. Kale's vision grayed out. He felt his ribs groaning under the pressure. The ship flipped backward. Suddenly, the blinding wall of the sun was gone from the front window, replaced by the terrifying sight of their own wake. And there, hanging in the fire, was the wormhole. It was no longer a calm sphere. Under the influence of the sun's gravity and the intake of negative energy, it was a raging vortex of violet and black, swirling against the backdrop of the solar surface, and racing toward it were 3 glowing torpedoes. "We have to beat them to the door," Ilara shouted, her voice sounding distant in Kale's ringing ears. She slammed the throttle forward. The ion runner dove toward the wormhole mouth. It was a game of chicken. The ship versus the missiles. 10 seconds, Kale yelled. Missiles. Closing. Come on, come on. Ilara urged the engines. The heat was unbearable now. Sparks were flying from the control panels. The windshield was beginning to crack. The wormhole filled their vision. It was a tunnel into the unknown, a rip in the fabric of the burning star. 5 seconds! Brace for temporal impact, Ilara screamed. The nose of the Eon runner pierced the event horizon of Malfay, just as the first torpedo struck the magnetic ring holding it. A blinding flash of white light swallowed them. The sensation was different, this time. The first jump had been a stretch, a pulling apart. This jump was a compression. Kale felt like he was being crushed into a diamond. The gravity of the sun followed them in, warping the tunnel, twisting the laws of physics. He heard Silas scream, a sound that looped and echoed endlessly. He saw Ilara frozen in a moment of determination, her hand on the throttle, motionless. Time didn't just slow down, it shattered. Kale saw visions. He saw the Aeon runner launching. He saw the ruined city. He saw the dinosaurs looking up at a meteor. He saw a city of glass and light floating in the clouds. Then the crushing weight vanished. Silence. Cold. Kale gasped, his lungs burning. The cockpit was dark. The screaming of the solar alarms was gone. The heat was gone, replaced by a biting chill. Status. Ilara's voice croaked from the darkness. Kale fumbled for the emergency power switch. The red auxiliary lights flickered on. The cockpit was a wreck. Panels were hanging loose. Silas was slumped in his chair, unconscious but breathing. "We're alive," Kale said, checking the hull integrity. "The ship is intact." Barely. Where are we? Elara asked.
Kale looked out the viewport. There was no sun, no earth, no stars. Outside the window, there was only a swirling, misty grey fog. It pulsed slowly, like a living thing. There was no depth, no distance. Just endless, shifting grey.
Sensors are dead, Kale said, tapping the glass.
No, wait. They aren't dead.
They are reading 0. 0 mass. 0 gravity. 0 time.
That's impossible. Elara unbuckled and floated to the window.
We have to be somewhere. I don't think we are anywhere, Kale said, a creeping dread settling in his stomach. Elara, look at the chronometer. Elara looked at the dashboard clock. The numbers weren't ticking forward, they weren't ticking backward. The digits were spinning, frantically, cycling through every number at once. A blur of meaningless data. We missed, Elara whispered. The gravity slingshot. It worked too well. We snapped the elastic so hard, it broke. So where are we? We aren't in the past, Elara said, staring into the grey void. We aren't in the future. We are in the gap. The space between moments. The bulk. The bulk. Hyperspace. The void outside of the universe, Elara said. We fell off the timeline, Kale. Suddenly, the grey fog outside shifted. A shape began to form. It wasn't a ship. It wasn't a planet. It was a clock. A massive, spectral clock face, floating in the mist, ticking backward. And standing on the hands of the clock was a figure. Do you see that? Kale asked, wondering if the oxygen deprivation was making him hallucinate. I see it, Elara said. The radio crackled to life. It wasn't the synthesized voice of the guard. It was a voice that sounded like wind chimes and grinding stones. Travelers, the voice whispered. You have gone too far. You have reached the edge. The edge of what? Kale managed to say, his voice trembling in the freezing air of the cockpit. The edge of the universe? The figure on the spectral clock did not move its mouth. The voice seemed to resonate from the hull of the ship itself, vibrating through the metal floor plates. The edge of the brain, the voice replied. You have left your dimension. You are now in the bulk. The space between spaces. Elara floated toward the viewport, mesmerized. She pressed her hand against the cold glass. M-theory, she whispered. Physicists theorized this. Our universe is just a membrane floating in a higher dimensional space, like a sheet of paper floating in a room. We just fell off the paper. Correct, the figure said. It stepped off the hand of the clock and drifted toward them. As it got closer, Kale realized it wasn't a person. It was a shape made of geometry-shifting triangles and spheres that constantly folded inside out. It only looked human because Kale's brain was trying desperately to make sense of it. We are the custodians, the entity said. We watch the membranes. We watch the bubbles of time float in the void. Usually, the bubbles remain sealed. Nothing gets out. Nothing gets in. But you used a star to punch a hole in the wall. We were trying to escape, Silas said, rubbing his head where he had hit it during the jump. The guard, the machines, they were going to kill us. The guard is a function of your own universe, the custodian explained calmly. Think of your timeline as a living body. When you created the wormhole, you created an infection, a loop that should not exist. The guard are the white blood cells. The guard are the white blood cells. They were created by the universe itself, through the agency of your future descendants, to heal the wound, to close the loop. They tried to blow us up, Cale argued. Dear, sometimes to heal a wound, you must cut out the infected tissue, the custodian replied. Elara turned from the window. So, did we destroy it? Did we destroy our universe? The custodian gestured with a limb that shimmered like oil on water. Look down. Cale, Elara, and Silas looked down past the nose of the Aeon Runner. There was no down in this grey void, but suspended below them was a breathtaking sight. It looked like a glowing, translucent loaf of bread, stretching infinitely in two directions. Inside the loaf, Cale could see everything. He saw galaxies spinning like tiny pinwheels. He saw stars igniting and dying in the blink of an eye. He saw a long, twisting thread of light that wove through the block, the timeline of humanity. That is your universe, the custodian said. The block universe. From this perspective, all time exists at once. The Big Bang is at one end. The heat death is at the other. And you, D, look closer. Cale squinted. He saw a tiny, messy knot sticking out of the side of the smooth block. It was a tangle of light, a chaotic loop where the timeline had twisted back on itself. That is your loop, the custodian said. That is the bridge you built. You can see how it distorts the structure. It pulls at the fabric. If it is not fixed, the tear will widen. The brain will rip. Your entire universe will spill into the bulk and dissolve. So, the guard was right, Silas whispered. His face grey. His face grey. His face grey. We are the villains. You are simply clumsy children playing with matches, the custodian said, not unkindly. You discovered fire before you understood how to put it out. Can we go back? Cale asked. How? Can we fix it? You are outside of time now, the custodian said. Here, distance is measured in probability, not kilometers. You can re-enter the block at any point you choose. You can jump back in. But if we go back, Elara said, her mind racing, the guard will be there. The moment we re-enter, we have mass again. We have gravity. They will sense us. They will destroy us, and the wormhole will collapse violently, destroying the timeline anyway. That is the dilemma,
the custodian agreed. The loop must be closed, but the act of closing it triggers the immune response. The entity drifted closer, its geometric form shifting into a perfect circle. However, it continued, you have an advantage now. You have seen the block. You know the shape of history. You can choose a moment to re-enter where the guard cannot stop you, a moment where the loop can be closed gently. Gently? Kale asked. How do you close a wormhole gently? You merge the twins, Ilara realized. We have Mouth A attached to our ship. Mouth B is back in the universe, somewhere in the past relative to us now. If we bring them together, physically touch them, the tunnel vanishes. The space smooths out. The energy dissipates. Answer. But Mouth B was lost, Kale reminded her. The chronos cut the tether. Mouth B is drifting in deep space, 50 years in the past. No, Silas interrupted. He was looking at the glowing block of the universe again. But look at the timeline. Nothing is lost here. It's all just there. He pointed to a specific point in the glowing thread. I see the Aeon Runner, Silas said, tracing the line with his finger on the glass. I see the moment you jumped. I see Mouth B drifting away. You can re-enter at that moment, the custodian said. You can intercept Mouth B before it is lost. But if we go back to that moment, Kale said, the Chronos is there, the future ship. It was shooting at us. Yes, Ilara said, her eyes narrowing. But we have something now that we didn't have then. What? We have the other end of the phone, Ilara said. She pointed to the cargo bay behind them. We have Mouth A, and we have the Ion Runner from the future, well, from the present. She turned to the custodian. If we re-enter the universe exactly at the moment we left it, we will have two ships. The past Aeon Runner, the one we abandoned, and this Eon Runner, the one we are in now. The temporal pincer movement, Silas breathed. We reinforce our past selves. We don't just reinforce them, Ilara corrected. We replace them. We have to make sure the loop is a circle, not a spiral. We have to go back and finish the job we started. The custodian rippled, turning a deep shade of blue. Be warned. Re-entering the brain from the bulk is violent. You are forcing 3D matter back into a container that doesn't want it. The shock wave will be immense, and once you are back inside, you are subject to the laws of physics again. Causality will bind you. If you die, you die. We understand, Kale said. He looked at Ilara. We started this. We have to finish it. There is one more thing, the custodian added. The energy required to puncture the brain and re-enter. Your ship does not have it. Your fusion drive is primitive. Kyle looked at the dead control panel. So we're stuck here, looking at the universe through a window? You are towing a singularity, the custodian noted, pointing to the wormhole mouth still clamped to the ship's underbelly. It contains the energy of a collapsed star.
If you reverse the polarity of your stabilizer, if you feed the negative energy into the bulk instead of the wormhole, it will act like a rocket, Ilara finished. A hyperdimensional rocket. But it will drain the wormhole. Mouth A will evaporate.
You only need it to last long enough to punch through,
the custodian said. The custodian said. Once you are through, you will have seconds to find mouth B before mouth A dissolves. You must connect them instantly. Seconds, Kale said dryly. Great. No pressure. The spectral clock began to fade. The custodian was retreating into the mist. Good luck, travelers, the voice echoed. The timeline is fragile. Try not to break it again. Wait, Kale shouted. Why help us? Why help us? Why do you care? The custodian paused, its form almost transparent now. Because, the voice whispered, we are not aliens, Kale. We are what you become. Millions of years from now, when you finally outgrow the brain, and then it was gone. They were alone in the grey void. The glowing loaf of the universe hung below them. Okay, Ilara said, clapping her hands. The sound was flat and muffled in the cockpit. We have a plan. We use the wormhole as a battery. We burn a hole in the wall of the universe. We dive in. We grab the other end of the tunnel. We close the loop. And the Kronos? Silas asked. The guard ship waiting for us? We'll have to improvise, Ilara said. She floated back to the pilot's seat. Kale, can you rig the stabilizer to invert? I can try, Kale said, pushing off the wall. I'll have to go down to the cargo bay and manually rewire the flow. It's going to be dangerous. If the containment field fails while we're in the bulk, we cease to exist, Ilara said. I know. Go. Silas, you monitor the timeline coordinates. Guide us in. We need to hit the exact second we left. Kale scrambled down the ladder to the cargo bay. The air was colder down here. The wormhole mouth was calm now, a shimmering pearl in the magnetic ring. It looked peaceful, considering it was a tear in reality. He opened the access panel on the negative energy generator, the device Silas had built 50 years ago, or 2 weeks ago, depending on how you looked at it. He swapped the emitter cables. He bypassed the safety regulators. Ready down here, Kale shouted over the comms. Coordinates locked, Silas's voice crackled. Aiming for Sector 44 Alpha. Time index, 12 hours, 0 minutes, and 1 second post-jump. Initiating inversion sequence, Ilara announced. Hold on. This isn't going to be like a normal acceleration. We are moving perpendicular to reality. Kale strapped himself into a jump seat in the cargo bay. He watched the wormhole. The generator whined. A beam of dark negative energy shot out, not into the wormhole, but outward, into the grey fog of the bulk. Newton's third law, for every action, there is an equal and opposite reaction. Even in hyperspace, the ion runner didn't move forward. It fell. The sensation was sickening. It felt like the floor had vanished. Cale's stomach lurched into his throat. Outside the hull, the grey fog ignited. The friction of entering the brain created a kaleidoscope of colors that Cale had never seen before. Colors that didn't exist in the visible spectrum. Breaching in 3, 2, 1, Ilara yelled. Crack! The sound was like a thunderclap inside Cale's skull. The grey void vanished instantly, replaced by the blinding, star-strewn blackness of normal space. Gravity returned with a vengeance. The ship groaned, metal twisting under the sudden reassertion of physical laws. "We're in!" Brokiel shouted, checking the cargo bay monitors. "We have mass! We have physics! Sensors online!" Silas called out from the cockpit. "I see it. I see the ion runner." Cale pulled up the external camera feed. It was the most surreal thing he had ever seen. Ahead of them, drifting in the vacuum, was them. It was the Aeon runner, as it had been moments after they jumped. The airlock was open, the tether was cut, and drifting away from it was the shimmering sphere of Mouth B. "And the Kronos?" Ilara asked. "There," Cale said. 3,000 kilometers off the port bow. They are scanning the wreckage. They think we're dead. "Not yet," Ilara growled. "Cale, Mouth A is destabilizing. We used too much energy for the jump. The ring is failing." Cale looked at the wormhole in the cargo bay. The sphere was shrinking. It was flickering like a dying light bulb. "We have maybe 30 seconds before it evaporates," Cale yelled. "If it vanishes before we touch Mouth B, the loop breaks and we get the paradox explosion." "I'm taking us in!" Ilara shouted. The Aeon runner, the future version, scarred and burnt, ignited its engines. It screamed toward the drifting Mouth B. The Kronos detected the new energy signature. The black ship turned, its sensors confused. It saw 2 ion runners, one drifting, one charging. "They are locking weapons," Silas warned. "They can't shoot," Cale yelled. "We are shielding the target. If they shoot us, they hit the wormhole." Ilara pushed the throttle to the stop. "I'm going to ram it." "Ram the ship?" "Ram the mouth," Ilara corrected. "I'm going to fly Mouth A directly into Mouth B." In the cargo bay, Cale watched the drifting sphere of Mouth B get closer on the screen. It was growing larger. "KL, release the clamps," Ilara ordered. "We have to drop Mouth A right on top of it." KL put his hand on the manual release lever. He watched the distance counter. .1000 meters, 500 meters, 200 meters. The Kronos fired. A beam of red energy sliced through space, aiming for the ion runner's engines. "Hit!" Silas yelled. "Stabilizers gone. We're spinning." The ship lurched. The cargo bay spun wildly. Cale was thrown against his harness. "I can't get a lock," Ilara shouted. "We're going to miss." Cale looked at the wormhole in the bay. It was vibrating violently. It was about to dissolve. He looked at the lever. Then he looked at the airlock. "Elara," Kale said, his voice calm despite the chaos. "The ship is too big. We can't align it in time. What are you doing?" "I'm going to guide it in," Kale said, manually. "Kyle, no." Kyle hit the release lever. The magnetic clamps opened. Mouth A, the shimmering pearl of the past, dropped out of the containment ring. It floated in the center of the cargo bay, unmoored. Kale hit the airlock override. The explosive bolts blew the cargo ramp door off into space. The vacuum sucked the air out instantly. Kale held on to the railing. The wormhole sphere was pulled out of the ship, drifting into the void. Kale kicked off the bulkhead. He flew out into space, using his suit thrusters to catch the drifting sphere. He grabbed the magnetic rim of the containment unit that was still attached to the sphere. He was now riding the wormhole mouth. "Kale!" Elara screamed over the comms. "Keep the Chronos busy!" Kale yelled. "I see Mouth B." "It's right ahead." He fired his suit jets. He was a human missile, pushing one end of a tunnel toward the other. Ahead of him, floating in the dark, was the other sphere. Mouth B. They were magnets. They were twins. They wanted to be together. The Chronos saw the human. The turret turned. "Target lock," the AI voice said in Kale's helmet. Anomaly detected. Kale didn't flinch. He pushed harder. The two spheres were 10 meters apart, 5 meters. The space between them began to warp. The light bent. The two mouths reached out for each other, streamers of blue energy connecting them. Kale felt the pull. It wasn't gravity. It was time. The years were rushing to meet each other. "Come on." Kale gritted his teeth. "Kale. Kale." Close the loop. He slammed the two spheres together. When Kale slammed the two spheres together, he expected fire. He expected a noise that would shatter his bones. He expected the end of the world. Instead, there was silence. It was not the quiet of a room, or even the silence of space. It was the silence of mathematics resolving itself. It was the feeling of a chaotic, screaming equation suddenly finding its answer. 0. The two mouths of the wormhole Mouth A, the Traveler, and Mouth B, the anchor met. For a nanosecond, they formed a perfect figure, 8 of light, a shape that twisted back on itself. Then the geometry collapsed. The tunnel didn't explode. It didn't implode. It simply ceased to be. The negative energy that held the throat open was cancelled out by the collision. The bridge between the past and the future evaporated, returning the borrowed mass to the universe in a gentle wave of harmless radiation. Kale was thrown backward, tumbling through the void. His suit alarms were screaming about radiation spikes, but they were fading fast. He spun around, trying to stabilize his thrusters. "Elara?" he gasped, his voice raspy. "Silas? We are here." Elara's voice came through, clear and strong. "We have you on visual." Kale stopped his spin and looked at the spot where the wormhole had been. There was nothing there. Just the empty, starry blackness of space. The rip in the fabric was sewn shut. And the Kronos? Cale asked, looking for the black ship that had been hunting them. Look to your left, Silas said. Cale turned his head. The Kronos, the sleek, terrifying warship from the future, was flickering. It looked like a ghost on an old television screen. Its hull was becoming transparent, revealing the stars behind it. Causality, Ilara whispered. We closed the loop. We prevented the time war. If the war never happens, the guard is never created. The ship is losing its anchor in reality. Does that mean? Cale watched as the Kronos turned into a mist of static. It means it never existed, Silas finished. It means it never existed. The black ship dissolved. It didn't blow up. It just faded away, erased from history like a pencil mark rubbed off a page. The timeline had healed. The white blood cells were no longer needed. I'm picking you up, Ilara said. Don't move. The battered Aeon runner, the ship that had lived through 50 years of history and survived a dip into the sun, glided toward Cale. The cargo bay doors were gone, blown off by the explosive bolts, but the magnetic field caught Carl gently and pulled him inside. Minutes later, the inner airlock cycled, and Carl fell onto the deck. Ilara was there instantly, pulling his helmet off. You crazy idiot, she said, but she was smiling, tears in her eyes. You actually did it. You pushed the magnets together. I thought it would kill me, Cale admitted, breathing the ship's air. Why didn't it? Because you didn't break the laws of physics, Silas said, stepping into the room. The old man looked lighter, as if a great weight had been lifted from his shoulders. You obeyed them. You restored the symmetry. The universe is grateful. Quote, Cale sat up. So, where are we? When are we? Ilara helped him stand and led him to the cockpit. The front windshield was cracked, and the console was sparking, but the navigation sensors were working. She pointed to the Earth. She felt a crash of sights. It hung in the window, blue and white and beautiful. It wasn't the grey, ruined cinder of 2150. It wasn't the shrunken pea of a black hole experiment. It was home. Date, Ilara read from the screen. May 14th, 2025. Time, 12:05 p.m. Cale did the math. We left at 10 a.m. We've been gone 2 hours. 2 hours of Earth time. Ilara nodded. But we have lived weeks. And Silas has lived a lifetime. They looked at the old man. He was gazing at the Earth with a look of pure longing. So we are back at the start, Cale said. But we have a problem. There are 2 Eon runners. There is this the one from the future, and there is the one that just launched 2 hours ago. No, Ilara corrected him. Think about the loop, Cale. The ship that launched 2 hours ago, that was us. We flew out, we opened the wormhole, we got chased, and we jumped into the tunnel. That ship is gone. It left this timeline to become this ship. So there is only one ship left, Cale realized.
This one. Exactly. The loop is a closed circle, Elara said. We are the only versions of us that exist. We didn't duplicate ourselves. We just took the long way around to get back to this moment. But we have this, Silas said, tapping the dashboard. We have a ship made of advanced alloys. We have a negative energy generator that works. We have knowledge of the future. We know about the war. We know about the mistakes humanity will make. The Time War, Kyle said, a shadow crossing his face. Silas said it started because nations fought over the wormhole technology. They wanted to control time. And now we are the only ones who know how to build it, Elara said. She looked at her hands. We are the carriers of the infection, or the cure, Silas said softly. Elara sat in the pilot's seat. Identify yourself. The radio crackled. It was Mission Control. The voice was familiar. It was the flight director, sounding panicked. Unknown vessel, you have entered restricted airspace. You match the signature of the Aeon runner, but you look different. You look damaged. Please respond. Elara picked up the microphone. She looked at Cale, then at Silas. Mission Control, this is Captain Elara Vance, she said steadily. We experienced technical difficulties. We have completed the experiment. We are coming home. Captain, you've been off radar for 2 hours, the voice replied, confused. We thought you exploded. Your telemetry went dead. What happened out there? A lot, Elara said. We'll debrief you on the ground. Vance out. She guided the ship down. The re-entry was rough. The hull was scarred from the solar corona and the battle with the guard, but the structure held. They descended through the clouds, the friction heating the windows one last time. They landed on the same concrete pad they had left that morning. The engines whined down and died. The silence that followed was heavy. What do we tell them? Cale asked as they stood by the airlock. Do we tell them about the future? About the ruins? About the guard? If we tell them, Silas said, we start the arms race. Every government will want to build a chronology guard. They will try to secure the timeline, and in doing so, they will destroy it. That is the paradox of security. So we lie? Cale asked. No, Elara said, opening the hatch. The bright sunlight of a Tuesday afternoon flooded the cabin. It smelled of grass and jet fuel, the smell of Earth. We tell them the truth about the physics. We tell them Einstein was right. Time is elastic. It can be stretched. End of chapter. She stepped onto the ramp. But, she added, turning back to them, we tell them that the engineering failed. We tell them that the wormhole was unstable, that it collapsed immediately, that time travel is physically possible, but technologically impossible. Ask, we kill the dream, Silas said. To save the future, Elara nodded. We hide the math. We bury the negative energy generator. We let humanity live in the present. The present is where we belong. They walked down the ramp.
A crowd of technicians and medics was running towards them. In the distance, Cale saw a young man running faster than the others, holding a clipboard. It was Silas. Young Silas, the graduate student who had just watched them launch. The old Silas stopped halfway down the ramp. He watched his younger self approaching. "This is going to be awkward," Cale whispered. "No." Old Silas smiled, tears streaming down his lined face. "I've waited 50 years to tell that idiot to get a haircut." Elara laughed, a sound of pure relief. She looked up at the sky. It was blue, empty, and free of drones. The block universe was vast, and the future was out there, somewhere. But it wasn't written yet. Einstein said the distinction between past, present, and future is only a stubborn illusion, Elara said. I think he was right. It's all just one long moment. And what a moment it is, Cale said. He took a deep breath. He wasn't a time traveler anymore. He wasn't a fugitive in the bulk. He was just Cale, standing on the ground, moving forward at the stately pace of 1 second per second. And for the first time in a long time, that was fast enough. "Come on," Elara said, putting a hand on his shoulder. "Let's go write a boring report." As they walked toward the crowd, the Aeon runner cooled behind them, its metal ticking as it contracted. Inside the cargo bay, the empty magnetic ring stood silent. The door to the past was closed. The door to the future was open. But it was a door that had to be walked through, one day at a time. The adventure was over. The work was just beginning.